Good morning, everyone. All right, Christian, so it sounds like we're ready to start now.
Yep, we're ready to begin. Currently, we have 300 attendees, and I think people are still joining in, so
Okay,
the number's going up.
why don't
So we
we
can
give
begin.
them a couple minutes and then we'll begin.
Sure.
All right, well, good morning, everybody, and thanks to those of you who are from across the state who are attending this. Just so you know, if you just hopped on, we're giving folks a few minutes to get connected here, and then we'll get rolling with this CARB workshop concerning Tier 5 standards.
Thanks, Kim. We'll give everybody one more minute. All right, well, why don't we begin? Just to remind everybody, we're recording today's workshop. So I'm Jenna Latt, and I'm the manager of the off-road control section. And thanks for joining us at our public workshop to discuss potential amendments to the off-road compression ignition regulation for new diesel engines, test procedures, and related programs, which we'll refer to today as Tier 5. This is the first in a series of workshops for Tier 5, and we're at the very beginning of a multi-year rulemaking process. The purpose of this remote workshop is to discuss possible concepts and strategies to reduce oxides of nitrogen and particulate matter emissions from new off-road diesel engines. During the workshop, CARB staff will discuss possible elements for more stringent exhaust standards from all off-road engine power categories, including those that do not currently utilize exhaust aftertreatment, such as diesel particulate filters, DPFs, and selective catalytic reduction, SCRs. Emission reductions from new engines are needed to meet our state implementation plan, or SIP, commitments in California, and Tier 5 is one of many measures in the proposed 2022 SIP. One quick note today is that today's Tier 5 workshop is a separate rulemaking process from the off-road in-use diesel fleet rulemaking that's currently under development by another section at CARB. Our focus today is on new diesel off-road engines. This is an opportunity to provide you with an overview of our current thinking and to solicit feedback from our stakeholders. We sent out a workshop notice again on Monday, notifying you that we've posted the slide decks so you can follow along with the slides during our presentation, with the exception of the Southwest Research slides, which you can contact us if you'd like a copy. Next slide. As you can see, we have a full agenda for today. We'll discuss the need for emission reductions, provide an overview of potential Tier 5 concepts. We'll also present our current ongoing demonstration project by our contractor, Southwest Research, followed by a question session at 11 a.m. We'll take a short lunch break and then come back at 12:30 for two more presentations, one on the low load cycle, and then finally one on off-road in-use compliance and testing, and then we'll have our second Q&A. Next slide. So as you note, we have three methods for entertaining questions today. One is by telephone. The second is by the Zoom Q&A box, which is probably the easiest if you're online with us. And the third is the raised hand feature that's also in Zoom. So as we are presenting, feel free to type in your question in the Q&A box, not the chat, and we will answer them verbally in the order received during the Q&A sessions. So we're not going to be, responding to your questions in the chat box. We'll do it during the Q&A session verbally. And then we'll split our time between the Q&A box and the raise hand feature and the telephone. So we're looking forward to hearing your comments and feedback. So now I'll hand over the program to our Mobile Source Control Division Branch Chief, Kim Heroy-Rogalski.
Thank you, Jenna, and good morning, everybody. So it's pretty exciting to be here and see. We actually have a count of how many folks are on. It's over 500 people. Usually at this point in a workshop, I'm looking out into the seats in the auditorium and trying to do an estimate. So it's pretty cool that we have that tally here. But it's wonderful that folks are taking the time to attend today. So as Jenna said, I'm the branch chief of the Mobile Source Reg Development Branch, and we work on all kinds of programs related to cutting emissions from heavy duty engines. Recently, one of our big projects was the heavy duty omnibus standards. And then further back in the past, the team worked on the off-road tier 4 standards. So it's pretty exciting to be kicking off this effort to hopefully really achieve some significant emission reductions from off-road diesel engines, and hopefully do it in a way that that makes sense and is cost effective, and that isn't too difficult for the affected stakeholders. I want to encourage everyone to please talk to us. Please talk to us at events like this, and please talk to us privately if you don't want to talk in a large event like this. We're always happy to take meetings and have discussions, and we definitely recognize that the industry understands their operations better than we do. So we really want to hear from manufacturers, really want to hear from folks who own and utilize off-road diesel equipment. This, as you're going to hear from Liang, this source category is very important, and particularly as other measures take effect and cut emissions from on-road sources, off-road sources become even more important, and that is why this is getting a lot of attention, and why you'll see, a big team sort of gathered here to work on this. So thanks for joining us today. This, as Jenna said, this is just the beginning. You're going to hear about a lot of possible elements that we're considering covering, and really want to hear your thoughts and your opinions about how we should do this. And we really want to have, if you're thinking of any data that you have that is relevant, we very much would love to see that data, because we need participation from you guys to make sure that we do the best we can, and that we're fully informed as we go through this rulemaking. Okay, so that's pretty much what I had to say. So let me hand it back.
Let's see, before we go to our moderator, Christian, we did get a couple chats, and people were asking whether the recording of the workshop will be available afterwards. And absolutely, yes, that's the whole purpose of recording it, and we'll put it on our YouTube channel, hopefully by the end of today or early tomorrow. Then we got another one that there's an echo distorting. I don't know if it's just my speakers, but anyhow, I'll turn it over to Chris and try to work on that.
Okay, thanks, Jenna. I'm Christian Bartolome. I'm with the Mobile Source Control Division. I'll be working on amendments related to real-world testing of Tier 5 engines. But today I'll assist by moderating today's meeting. And with that, I'm going to introduce our first speaker, Dr. Lang Lu, who's from the Air Quality Planning and Science Division. And I'm going to switch over the slides for that presentation.
Thanks, Christian.
Here we go.
Okay, hi everyone. So in this presentation, I will give you a brief overview of the emission inventory modeling for off-road diesel sector, and also the need for emission reductions in the sector to achieve our air quality and climate goals. So here's a brief outline of the presentation. First, I'll cover California's air quality and greenhouse gas emission goals, and followed by the emission reductions that are needed to achieve those goals. And then I'll cover the emission contributions from off-road diesel engines, as well as the potential emission benefits for the Tier 5 standards. Next slide, please. So here is a graph showing California's pathway to achieve our air quality and climate goals. As you can see, the different state implementation plan, or SIP, attainment years for South Coast and San Joaquin Valley. So the two areas with the most challenging air quality problems in the nation. So near-term targets include 2023 for ozone, and 2024 and 2025 for PM 2.5, and midterm targets are 2031 and 2037 for South Coast ozone standard. There's also an immediate need to achieve reductions in disadvantaged communities in AB 617, which have target years in 2024 and 2025. Our climate goals include the midterm target in 2030 for greenhouse gas emissions to stay 40% below the 1990 level, and then the longer term targets in 2045 for carbon neutrality, and 2050 for GHG emissions to be 80% below the 1990 level. Next slide, please. So to achieve those goals, additional progress is definitely needed. As you can see from this chart, EPA revised the 8-hour ozone standard to 70 ppb in 2015, and we have 19 areas in California that are designated non-attainment. So in this chart, you can see, as I mentioned before, South Coast and San Joaquin Valley are the extreme non-attainment areas. We also have other regions that are severe or serious non-attainment. So we definitely need reductions to achieve our goals. Next slide, please. So here is a chart showing the potential reductions needed to for South Coast to meet the ozone standard in 2037. So on the left side, you can see the baseline emissions statewide, baseline NOx emissions from all sectors. And on the right side, it shows the carrying capacity, which is the maximum allowable NOx emissions to meet the ozone standard for South Coast, which is about 55 to 85 tons per day. So we need over 70% reduction for South Coast to achieve the ozone, to meet the ozone standard. And we need emission reductions from all the sectors as much as we can. And off-road will be an important contributor to this. Next slide, please. So here's a closer look at off-road zone in California's NOx emissions. So this figure shows NOx emissions from the mobile source sector, and the dashed line shows the on-road emissions, and the areas shows off-road emissions by sectors. You can see off-road sector has surpassed on-road as the largest statewide NOx emitter in 2017. And as our cars and trucks get cleaner, off-road sector becomes even more important in the future. And additional reductions will definitely help us to meet our air quality goals. Next slide. So here's a more detailed look at the statewide NOx emissions by sector in 2017. So this is baseline emissions. And you can see the off-road diesel equipment make up about 16% of the total statewide NOx emissions. And by off-road diesel equipment, we mean like construction and mining equipment, like industrial, agricultural tractors, cargo handling equipment, transportation refrigeration units, portable equipment, ground support equipment, and etc. So they also contribute to about 1% of the total greenhouse gas emissions. And these are the equipment that will be impacted by Tier 5, and their emissions will be reduced by Tier 5 standard. Next slide, please. So here is a brief overview of how we develop emission inventory for the off-road sector. So the emission inventory, it calculates the emissions from all combustion engines in the state. So to put it simply, emissions is the activity times emission factor. Activity here is horsepower hour, which we use to quantify the engine's annual activity. So it's usually population times the average annual hours of engine times its rated horsepower and times the load factor. By load, we mean the percentage of the maximum engine power used on average by an engine while it's operating. And the data source for those specific variables usually come from like survey or industries reporting data to CARB. And next is emission factor. So emission factor, usually we determine it from the US EPA certification data or real world emission testing from PAMS. One thing I want to point out, so we do have a fuel correction factor usually applied to emission factors. Since California diesel is usually cleaner than federal diesel, we have more strict emission, diesel standard. So a fuel correction factor is applied to the emission factor. And one thing I want to point out is also that emission factor is different than emission standard. So in like emission factor for engine manufactured in a certain year can be either higher or lower than the emission standard. So it depends on whether the manufacturer has emission credits, then they could have manufacture engines with higher emissions, and or they will try to, if the technology allows, they can make the engine cleaner than what the current emission standard requires. Next slide, please. So here is a summary of the existing emission standards by tier stand for the off-road diesel engines. You can see from tier 0, that's pre-1996, we come a long way to tier 4, and tier 4 final is like 70 or 80% cleaner than tier 0. And so tier 4 final here, it does exclude engines less than 75 horsepower or over 750 horsepower. But you can see tier 4 final was facing, tier 4 was facing through about 2008 to 2015, and it's been like 6 or 7 years since we passed tier 4 standard. And I think it's time for us to pass tier 5 standard, and because the off-road emission standard is still much higher than the on-road standard for heavy duty trucks. And then we need to clean up the off-road sectors. Next slide. So here is a potential emission reduction from the tier 5 standard. You can see the emission reduction from tier 4 final stand by horsepower being here on this figure. So it ranges about 50 to 90% reduction for tier 4 final, depending on the horsepower range. So it's lower reductions for like lower horsepower being, and for extremely high horsepower being, but from like 75 to 750, the majority of the engines will need to reduce NOx emission by about 90% and PM emission by about 75%. Next slide, please. So in the state mobile source strategy, we had a scenario to quantify the potential emission reductions from tier 5 standards. So the proposed implementation starts in 2028 for non-preempted engines and 2030 for preempted engines. So by federal preempted engines here, we mean because the Clean Air Act did not grant CARB the authority to set emission standards for engines that are less than 175 horsepower and are used in construction or farm industry. So we'll need US EPA's action to actually reduce emissions for preempted engines. So here's a figure showing the NOx emission reduction from tier 5 standard in this mobile source strategy scenario. In like San Joaquin Valley, South Coast, and statewide. You can see we can reduce about 4 tons per day NOx emission in 2030, about 10 in 2035, and about 20 in 2050. So that's a significant amount of NOx reductions. And also interesting to show, you can see the red bar showing the emission reduction from non-preempted engines, and the blue bar shows the emission from preempted engines. The emission reduction for those two types of engines are actually almost exactly the same. So we definitely need US EPA's action as well to help us achieve our goals in reduce the NOx emissions. And that's it for my presentation. Thanks. I pass it back to Jenna or Christian. Oh sorry, Christian.
Thank you, Dr. Meng Liu. I'm going to change the slides for our next presenter, Jeff Laurie with the Mobile Source Control Division. Bear with me as I open that. Let's see here. Yeah. Okay. You can take it away, Jeff.
All right, great. Thank you so much, Christian. And thank you everyone for taking part in today's workshop. CARB's goal is to develop effective regulations, and your participation in this early phase of the Tier 5 regulatory development process is essential to making that happen. My name is Jeff Lowry, and I'm CARB's lead staff for new off-road diesel engine regulations. Make the distinction new when referring to these regulations to avoid confusion with CARB's in-use off-road diesel fleet regulation that addresses emissions from off-road equipment already in service. The in-use off-road diesel fleet regulation is part of a separate rulemaking process at CARB and will not be part of the Tier 5 rulemaking. Rather, I will focus on discussing potential amendments to the requirements that apply to engine and equipment manufacturers intending to certify new off-road diesel engines for sale in California. These potential amendments to the existing Tier 4 requirements are intended to usher in the next generation of more stringent off-road diesel emission standards in California and are referred to in this presentation as Tier 5. None of the potential amendments I'll be discussing today should be considered official or final proposals. Rather, staff is looking for feedback on the concepts presented, good or bad, and even for alternative suggestions that would accomplish our emission reduction goals in a more expedient manner. Next slide, please. Here's an overview of the topics I'll be covering throughout the presentation. First, I'll identify some of the strategies being considered to collectively address off-road emissions in California. Next, I'll briefly describe what the Tier 5 program is, why it's needed, and what we hope to accomplish through it. After that, I'll summarize the existing Tier 4 standards, followed by staff's consideration of potential Tier 5 amendments to those standards. Next, I'll present potential certification requirements that may be needed to ensure off-road emissions are being properly controlled in use. I will also introduce the topic of in-use testing and compliance procedures for off-road diesel engines. In the final part of my presentation, I'll identify existing provisions in the new off-road diesel regulations that could slow the propagation of new Tier 5 standards into the fleet. Next slide, please. To provide some perspective of CARB's overall plan to reduce emissions in the off-road sector, here's a timeline of CARB's proposed strategies for the next few years. At the beginning of the timeline, we see a 2021 board adoption date for regulations requiring equipment powered by small off-road gasoline-fueled engines to transition to zero-emission technologies. In that same year, CARB intends to expand the Clean Off-Road Equipment Voucher Program beyond just freight equipment to include construction, agricultural, and lawn and garden equipment. Although not shown in the timeline, CARB also intends to propose zero-emission requirements in early 2022 for truck-based transport refrigeration units less than 19 kilowatts, which would be scheduled to begin in late 2023. In 2022 or 2023, CARB staff will ask the board to adopt electrification requirements for forklifts and to update the in-use off-road diesel regulation for adding cleaner vehicles to the fleets. In 2024, staff will present the Clean Off-Road Fleet Recognition Program, which is currently under development for board consideration. In late 2024 or early 2025, staff plans to propose Tier 5 amendments to the off-road diesel engine regulations for board consideration. These potential amendments are the subject of today's workshop presentation. Also in 2025, staff intends to propose a regulation that targets off-road applications for which manufacturers would be required to produce zero-emission off-road equipment or powertrains as a percentage of their annual statewide sales volumes. And this would be based on the projected feasibility of zero-emission technology. Next slide, please. Tier 5 is the next generation of more stringent emission standards for off-road diesel engines, utilizing advancements in emission control technologies since the adoption of the current Tier 4 standards in 2004. California Governor Newsom signed Executive Order N7920 on September 23, 2020, requiring the state of California to transition to 100% zero emission off-road vehicles and equipment by 2035 were feasible. As illustrated in the previous timeline slide, Tier 5 is one of several complementary programs that are necessary to clean up the off-road sector in accordance with Executive Order N7920. Tier 5 off-road diesel emission standards would ensure that off-road equipment for which zero emission technology is not feasible will still be as clean as possible. Next slide, please. Here we see the current Tier 4 final off-road diesel engine standards. They are the same federally and in California. These standards were adopted in 2004 based on the best available control technologies from that time, which included diesel particulate filters and oxides of nitrogen, NOx for short, adsorbers. Today, most manufacturers use selective catalyst reduction, SCR for short, to control NOx emissions. And more than 50% of the manufacturers who certify in California are able to comply with particulate matter standards, PM for short, without the use of diesel particulate filters. There have been no changes to these Tier 4 standards since 2004. Next slide, please. To demonstrate that an engine complies with required emission standards, the engine must be operated over a repeatable duty cycle that is representative of how the engine is typically operated in the real world. The non-road transient test cycle, NRTC for short, is an international duty cycle for evaluating off-road diesel engine emissions performance. It was developed by EPA together with the European Union for certifying Tier 4 off-road diesel engines. The cycle is currently used in the United States, Europe, Japan, and of course, California, although the cold start waiting portions of the cycle vary by location. The NRTC is comprised of duty cycle elements from agricultural tractors, backhoe loaders, crawler dozers, excavators, arc welders, skid steer loaders, and rubber tire loaders. Despite the wide variety of off-road applications and power ranges present in the off-road sector, the NRTC was deemed to be an adequate and universal representation of off-road diesel engine activity for the purpose of measuring emissions. This assumption, however, may no longer be completely sufficient with respect to engine operation during low loads and low temperatures. This topic will be explored in greater detail later in the workshop. There are other test cycles for certifying off-road diesel engines during steady state operation. These are selectively applicable to both constant speed and variable speed type engines, but are most useful in evaluating engines used in equipment such as generators and pumps that typically operate at governed speeds for prolonged periods of time. Off-road engines are also required to comply with opacity limits to ensure PM emissions control and use, although Tier 4 final engines are generally exempt. Manufacturers are currently required to certify that their off-road diesel engine families comply with the same not to exceed requirements, NTE for short, as for heavy-duty on-road diesel engines. But unlike heavy-duty on-road diesel engines, there are no requirements for a manufacturer-run off-road diesel in-use testing program. Mr. Ivan Castillo will address the need for an off-road in-use testing program later in the workshop. Next slide, please. Off-road diesel emission controls have matured considerably over the 17 years since Tier 4 final standards were first adopted. And current Tier 4 standards no longer represent best available control technologies. As of the 2018 model year, over 50% of the Tier 4 final engine families in California greater than 19 kilowatts were certified without diesel particulate filters. As presented earlier by Dr. Liang Lu, on the emissions inventory in California, additional emission reductions are needed for attainment with federal and state ambient air quality standards. Emissions from off-road diesel engines are already a higher contributor to the inventory than heavy-duty on-road engines, and the difference is continuing to grow. With the adoption of more stringent heavy-duty on-road engine standards as part of the 2020 heavy-duty omnibus regulation, off-road standards now lag on-road standards significantly, despite there being nearly identical diesel engine technologies used in their design. Off-road diesel engines pose a greater cancer risk to disadvantaged communities because off-road engines are frequently delegated to singular locations next to highways, distribution centers, ports, construction sites, and rail yards. As mentioned in the previous slide, off-road diesel engine emissions control may not be characterized completely by the current NRT transient test cycle. Staff believes that an additional low load certification test cycle may need to be developed to ascertain emissions performance during prolonged operation at low loads where exhaust temperature becomes insufficient for SCR to adequately control NOx emissions. Dr. Yi Tan will address the need for an off-road low load certification cycle later in the workshop. Next slide, please. The Federal Clean Air Act prohibits California from regulating new farm and construction equipment less than 175 horsepower. This includes most off-road equipment between 25 and 175 horsepower, and many equipment types less than 25 horsepower, including mini excavators, backhoes, skid steers, wheel loaders, pumps, and compressors, just to name a few. Federally preempted equipment is estimated to be responsible for approximately 50% of the emission benefits from potential Tier 5 standards in California, should EPA adopt similarly stringent off-road diesel standards for preempted equipment. Should EPA retain Tier 4 off-road diesel standards for preempted equipment, however, the projected emission benefits in California would be cut approximately in half. The bottom line here is that California needs EPA cooperation in cleaning up the off-road so that California can comply with federal ambient air quality standards and protect the health of California's residents. Next slide, please. This is the same chart presented earlier by Dr. Liang Liu, illustrating the potential emission benefits in California from adopting Tier 5 standards. The benefits are shown for both federally preempted equipment and the non-preempted equipment that CARB is authorized to regulate. As mentioned in the previous slide, the federally preempted equipment would be responsible for approximately half of the benefits from a harmonized 50-state Tier 5 regulation. Next slide, please. Due to the maturation of diesel engine emission control technologies over the last 17 years, staff believes that additional reductions in PM and NOx are now feasible. Although more stringent hydrocarbon and carbon monoxide standards could also be feasible, they are not being investigated independently at this time. Southwest Research Institute is currently demonstrating the feasibility of reducing NOx emissions by 90% and PM emissions by 75% from the Tier 4 final standards on a 6.8 liter John Deere tractor engine using the latest generation of diesel particulate filters and enhanced SCR configurations. It is expected that the results from this demonstration will be transferable to engines between 56 kilowatts and 560 kilowatts. Mr. Christopher Sharp from the Southwest Research Institute will update us on the status of this demonstration later in the workshop. Based on the potential for electrification and hybridization, as well as currently reported certification levels, staff believes that reductions in PM and NOx up to 75% are feasible for engines less than 56 kilowatts, and reductions of at least 50% for engines greater than 560 kilowatts. Staff is also considering a zero emissions requirement for off-road equipment powered by diesel engines less than 19 kilowatts. As indicated in the off-road strategies timeline, a zero emission requirement will be proposed later this year for gasoline-fueled small off-road engines such as chainsaws and string trimmers. The electrification of similarly powered off-road diesel equipment is a logical next step, especially considering the current commercial availability of battery-powered equipment in this power range. Next slide, please. CARB is also considering a new tailpipe standard for off-road diesel engines, similar to the Phase 1 carbon dioxide standard previously adopted for heavy-duty on-road diesel engines, which reduced tailpipe emissions from between 5 and 8.6% from prospective baselines. Southwest Research Institute is investigating the feasibility of an off-road diesel engine carbon dioxide standard using dynamic cylinder deactivation technology. Although the contribution from off-road diesel engines to the greenhouse gas inventory, GHG for short, is comparatively small with respect to other sources such as on-road vehicles, locomotives, ships, aircraft, and refineries, the off-road contribution is not insignificant. Carbon dioxide emissions from off-road equipment were estimated to be 2.83 million tons equivalent in California for calendar year 2018 by CARB scoping plan. To achieve the ambitious GHG levels mandated by Senate Bill 32, reductions from all sources must be considered. Next slide, please. According to construction and agricultural activity data from CARB's contracts, off-road diesel engines frequently operate under low load conditions up to 50% of the time. NOx emissions generated by a 6.8 liter John Deere engine are up to 19 times greater than the emissions from the same engine over the NRTC, based on recent testing by the Southwest Research Institute over their proprietary low load application cycle, LLAC for short. This demonstrates that low load operation can significantly affect off-road diesel engine emissions performance in an adverse manner. Excuse me. Dr. Yi Tan will address CARB's off-road low load cycle development efforts later in the workshop, but I wanted to tee up this discussion here first with respect to Southwest Research Institute's LLAC. The LLAC is a composite of real-world duty cycles provided by John Deere from 4 different types of John Deere equipment. The LLAC doesn't represent a lot of diversity with respect to off-road applications, manufacturers, or power categories, but it does demonstrate the effects of typical SCR performance under real-world low-load operation. Staff requests comments on the sufficiency of the LLAC to become the potential future regulatory low-load cycle for Tier 5 to ensure that emissions are adequately controlled during low-load off-road operation. We don't expect an answer today, but please give this thoughtful consideration and let us know what you think and why you think it. Next slide, please. Here we see a comparison of tailpipe NOx emissions over current off-road certification test cycles and the LLAC. The chart clearly shows that off-road diesel low-load operation is not being adequately represented by the NRTC certification test cycle. Again, Dr. Yi Tan will address this topic more in his presentation later today. Next slide, please. Now let's turn our attention to off-road hybrid powertrains. Manufacturers are currently allowed to use certified off-road or on-road engines when producing off-road hybrid powertrains. Unlike for heavy-duty on-road hybrid powertrains, there is no modeling approach available for certifying the powertrain as a complete unit and claiming emissions credits for the powertrain versus just the engine. Staff requests comments on the need for CARB to develop an off-road certification procedure for hybrid powertrains so that manufacturers can claim additional emission credits versus those from the engine alone. This would aid in complying with a future Tier 5 standard. Among our requests for comments would be answers to questions such as, would the recently adopted heavy-duty on-road hybrid powertrain test procedures be sufficient for certifying off-road hybrid powertrains? Would there be a need to identify off-road specific inputs for the current model, or should manufacturers be allowed to use on-road certified hybrid powertrains in off-road hybrid applications as is? How would credits be calculated in that case? As with our request for feedback regarding the low load application cycle, we don't expect an answer today, but please give this request your consideration and let us know what you think. Next slide, please. Staff is considering a proposal to lengthen useful life periods for engines between 56 and 560 kilowatts. For the purpose of CARB's emissions regulations, useful life is the period over which an engine must conform to applicable emission standards. The current useful life periods for off-road diesel engines are 5 years or 3,000 hours for engines less than 19 kilowatts and for engines less than 30 kilowatts rated at constant speeds over 3,000 revolutions per minute. 7 years or 5,000 hours for engines between 19 and 37 kilowatts, and 10 years or 8,000 hours for engines greater than or equal to 37 kilowatts. Current industry publications suggest that major overhaul is typically needed between 12,000 and 15,000 hours for the majority of off-road diesel engines greater than 56 kilowatts. Longer, more representative useful life periods necessitate emissions control for a greater portion of the off-road engine service life, which will reduce in-use emissions more than just a change to the standards alone. Southwest Research Institute is currently demonstrating the feasibility of a 12,000 hour useful life period on the same John Deere 6.8 liter engine being demonstrated to comply with potentially lower off-road diesel Tier 5 standards. This potential useful life proposal would target engines between 56 and 560 kilowatts, which currently have useful life periods of 8,000 hours. Please let us know your thoughts on the need to extend useful life. Provide data as to why the current 10-year period is sufficient, or should CARB consider amending that value as well. Next slide, please. Staff is considering a proposal to lengthen the existing warranty periods for off-road diesel engines. The current warranty periods are 2 years or 1,500 hours for engines less than 19 kilowatts and for engines less than 37 kilowatts rated at constant speeds over 3,000 revolutions per minute, and 5 years or 3,000 hours for engines greater than or equal to 37 kilowatts. Longer warranty periods have the potential to provide emission benefits by incentivizing the timely repair of emissions-related malfunctions. Timely repairs can result in less overall downtime and potentially longer service lives, analogous to a properly maintained engine. Emissions-related malfunctions that occur outside of warranty may go unrepaired to avoid expenses, especially if the malfunction does not drastically affect equipment performance. Staff requests feedback on the types of extended warranty periods currently offered by engine and equipment manufacturers. In particular, is there a demand for longer warranty periods than currently required by the regulations? Conversely, are the current off-road diesel engine warranty periods sufficient to address emissions-related malfunctions in a timely manner, and why? Next slide, please. Staff is considering a proposal to adopt idling reduction requirements for off-road diesel engines. Data from an assortment of in-house and contracted studies compiled by staff suggests that off-road diesel equipment frequently idle for 50% of their operating time. Prolonged idling reduces exhaust temperature, which in turn reduces the effectiveness of SCR to control NOx emissions. Heavy-duty on-road diesel engines are currently required to limit idle to 300 continuous seconds before shutting off the engine, or to 30 grams per hour NOx emissions on the idling test cycle. The Southwest Research Institute has been contracted by CARB to demonstrate the feasibility of stop-start technology on a 6.8 liter John Deere engine in support of a proposal to adopt off-road engine idling reduction requirements. Staff requests feedback, including data, to help formulate an appropriate proposal to reduce off-road diesel engine idling. Specifically, what is the maximum amount of idling that should be allowed before requiring a mandatory shutoff of the engine? What would be an appropriate idling standard and test cycle for off-road diesel engines? Would only one standard be sufficient for all off-road diesel applications? Please let us know what you think. Next slide, please. Staff is considering adopting the provisions in sections 1039.110 and 1039.665 of Title 40 of the Code of Federal Regulations pertaining to the use of engine deratement to induce the repair of malfunctioning SCR systems and the replenishing of diesel exhaust fluid, DEF for short. Engine deratement is the intentional and incremental reduction of engine performance based on the detection of low DEF fill levels or malfunctions of the SCR system. SCR is the primary technology for reducing NOx emissions from off-road diesel engines. In order for this technology to function properly, vehicle operators must periodically replenish DEF. Sensors relay information regarding DEF fill levels and quality to the onboard computer, which responds by derating engine performance until DEF fill levels and quality have been restored to normal. EPA adopted inducement provisions for SCR systems in 2014. EPA also codified requirements allowing the inducement protocols to be temporarily suspended during emergency situations in which equipment operation is necessary to protect lives, such as during a fire. Staff believes that additional safeguards may need to be adopted regarding these temporary override provisions to prevent the provisions from being abused to the detriment of NOx emissions control. Staff requests feedback regarding the necessity of amendments to the SCR inducement override provisions, and also comments on expanding inducements to other emissions-related malfunctions beyond just SCR. Next slide, please. Staff is considering a proposal to adopt onboard diagnostic requirements, OBD for short, for off-road diesel engines. OBD could potentially offer many benefits with respect to in-use emissions reductions. As I mentioned previously, emissions-related malfunctions that occur outside of warranty may go unrepaired to avoid expenses, especially if the malfunction does not drastically affect equipment performance. OBD has the potential to identify emissions-related malfunctions in a timely manner during the warranty period, thus incentivizing the timely repair of these malfunctions because the manufacturer, not the equipment owner, is liable for the repair. Timely repairs can result in less overall downtime and potentially longer service lives, analogous to a properly maintained engine. OBD also offers the advantages of being able to facilitate in-use inspections via the presence of fault codes and an illuminated malfunction indicator light, to screen for problematic emissions control performance in use, and to aid in compliance testing and the application of corrective actions when necessary. Given the technological similarities between off-road and heavy-duty on-road diesel engines, many of the OBD monitoring strategies that already exist in the on-road should be readily transferable to the off-road. Next slide, please. Some of the monitoring strategies being considered for potential inclusion in an off-road diesel OBD program include circuit continuity and out-of-range checks. These checks are accomplished by continuously verifying the presence of appropriate voltage levels and electrical resistance for the components being monitored. Staff is also considering OBD monitors that would periodically verify the proper performance of SCR systems, diesel particulate filters, and critical components such as NOx and even possibly ammonia sensors. The proper operation of these systems and components are essential for maintaining NOx and PM control over the life of the off-road diesel engine. OBD strategies for these systems and components already exist for heavy-duty on-road diesel engines and could be transferable to off-road diesel engines with some recalibration efforts. Other critical components that staff is considering for off-road OBD monitoring are the sensors used by the engine's onboard computer to derate engine performance as a means of inducing vehicle owners to replenish DEF and to make repairs to the SCR system in a timely manner. Staff is also considering the standardization of communication protocols, fault codes, data stream parameters, and scan tool connectors to ensure universal access to OBD information, thus facilitating the diagnosis and repair of emissions-related malfunctions. Staff is also considering the inclusion of NOx and carbon dioxide tracking capability, similar to the real emissions assessment logging already required for heavy-duty on-road engines. CARB's onboard diagnostics branch will be lending their expertise to this potential effort to bring standardized OBD to the diesel off-road. Staff requests feedback on this potential proposal to adopt OBD for off-road diesel engines. Please let us know your thoughts on which components should be monitored by the OBD system and which types of equipment and power ranges should be candidates for off-road OBD. Next slide, please. Staff is considering a proposal to adopt a manufacturer-run in-use testing program for off-road diesel engines. At present, engine manufacturers are only required to submit a statement of compliance at the time of certification that their engines will comply with NTE limits, which are essentially the same as the NTE limits that heavy-duty on-road diesel engines must meet. In-use testing is necessary to ensure that emissions are being controlled during real-world operation, and not just on a dynamometer in a controlled environment over a repeatable test cycle. CARB has already adopted manufacturer-run in-use testing programs for light and heavy-duty on-road engines, including NTE and the recently adopted 3-bin moving average window approach. The European Union adopted work-based in-use off-road testing and reporting requirements as part of its non-road stage 5 standards. But the results from these tests are not yet used to determine compliance or trigger corrective action. Mr. Ivan Castillo will present additional details on a potential Tier 5 in-use testing program for off-road diesel engines later in this workshop. Staff requests suggestions for an appropriate manufacturer-run in-use testing program. Next slide, please. In the remaining slides, I'll identify a problem that could potentially derail Tier 5 emission benefits in California, as well as existing provisions in the off-road diesel new engine regulations that present obstacles to a cleaner fleet in California. Next slide. At present, the Tier 4 off-road diesel standards for new engines are the same in California as they are in the rest of the nation. Because of this, the incentive to purchase off-road diesel engines and equipment out of state for use in California is relatively small, despite some differences in taxation. This could change, however, should California adopt Tier 5 standards without EPA harmonization for federally certified non-road diesel engines. Manufacturers cannot introduce new off-road engines into California unless they meet California certification requirements. However, current statute and regulations do not prohibit the transfer of off-road equipment into California with only minimal hours of use. This has the ability to greatly diminish emission benefits in California by circumventing the Tier 5 standards, and illustrates the importance of federal alignment with California's Tier 5 standards and also zero emission requirements to ensure that this situation is never realized. As I mentioned previously with respect to federally preempted engines, California needs EPA cooperation in cleaning up the off-road so that we can comply with federal ambient air quality standards and protect the health of California's residents. Next slide, please. Both CARB and EPA allow existing off-road diesel engines to be repowered with new engines of a less stringent emissions configuration, or with rebuilt or remanufactured engines also of a less stringent emissions configuration than otherwise required for current model year engines. EPA limits the installation of new replacement engines after the equipment exceeds a certain age, but rebuilt or remanufactured engines can be installed indefinitely. CARB has in-use off-road programs that phase out diesel engines from fleets in favor of cleaner, more recent model year engines, but this typically happens over many years. The repowering of existing equipment with less than the cleanest engines available delays the propagation of cleaner new engines into the California inventory and reduces the effectiveness of the new standards. The chart in this slide shows a comparison between new engine sales in California on the right, the summation of reported new replacement engine, rebuilt engine, and remanufactured engine sales reported to CARB on the left, and an estimate of only remanufactured engine sales in the middle, derived from Production Engine Remanufacturers Association data, PERA for short. There's a huge discrepancy, almost 6 times, between what's reported to CARB versus staff's extrapolation of PERA data, which suggests that remanufactured engines make up approximately 10% of all annual sales versus the 2% being reported to CARB. On top of this, the PERA data only include remanufactured engines, whereas the CARB data also include rebuilt and new replacement engines, suggesting that the difference could be even larger. Staff is considering a proposal to revise the tracking, record keeping, and reporting requirements for these categories to ensure that fleet emissions remain low and do not circumvent the new engine standards. Staff requests comments on how to improve these provisions to minimize their effects on emission benefits. Next slide, please. The transition program for equipment manufacturers, flexibility for short, is administered at the federal level and allows equipment manufacturers lead time to modify their chassis to accommodate the installation of newly designed engines after a change in standards. During this lead time, equipment manufacturers are allowed to continue selling new equipment with previous model year engines for a portion of their production over a period of up to 7 years. Flexibility engines dilute the emission benefits of the new standards. The exact number of flexibility engines in California is unknown because, as a participant in the federal program, California could be getting more or less than its fair share of these dirtier engines based on national sales volumes. The Bournes College of Engineering, Center for Environmental Research and Technology, CSERT for short, concluded in a CARB-sponsored 2018 research project that the accurate distribution of flexibility engines in California is unknown because of insufficient reporting and record-keeping requirements at both the state and federal levels. The Tier 4 flexibility program is scheduled to end this year. With respect to Tier 5, staff is inclined to believe that additional flexibility allowances may not be needed if the footprint of Tier 5 control technologies is consistent with that of Tier 4 control technologies, which looks likely at this time, according to research being performed by the Southwest Research Institute. Staff requests comments on the necessity of a new flexibility program for equipment manufacturers as part of the Tier 5 rulemaking. Additionally, staff requests feedback and data on the necessity of providing flexibility to vertically integrated equipment manufacturers who make both the equipment and the engine installed in the equipment. Next slide, please. These pie charts show a comparison of the percentages of annual sales for flexibility engines reported in California versus nationwide. As CSERT concluded in its 2018 research project, there's currently no reliable method of tracking the number of flexibility engines being distributed among the 50 states. Therefore, the data used to create these pie charts must be considered limited. However, based on the data we have, it appears that California is receiving more than its fair share of dirtier flexibility engines at 5.11% versus 3.62% nationally. These data were tabulated for the 2018 model year, which was near the end of the Tier 4 flexibility program for most off-road diesel power categories. It is therefore likely that flexibility engines comprised a much larger percentage of annual sales earlier on when equipment manufacturers first began transitioning their chassis to accommodate the new Tier 4 engines. Staff requests comments on how to improve tracking and reporting requirements to ensure that flexibility engines, if they are needed and allowed under the Tier 5 regulation, won't disproportionately skewer the emission benefits from the new standards in California. Next slide, please. The Averaging Banking and Trading Program, ABT for short, is also administered federally and allows engine manufacturers the option to comply with current model year standards by averaging emission levels. ABT allows some engine families to be certified to less stringent emission levels than the Tier 4 standards, so long as the averaged emission levels from all engine families or averaging sets remain within the standards. ABT is a cost-effective compliance mechanism that gives manufacturers the option to devote resources towards developing cleaner engines than otherwise required for a portion of their product lines. Unfortunately, ABT could subject some areas of the state to higher emissions, depending on the population of engines in those areas with less stringent emissions configuration. Similar to the flexibility program, the effects from ABT engines in California are unquantifiable because as a participant in the federal program, California could be getting more or less than the national average of higher emitting ABT engines. Unlike the flexibility program, however, ABT is an ongoing provision for equipment manufacturers that does not have an end date. Staff requests comments and suggestions on how to improve the current ABT record keeping and recording requirements to better track ABT engines in California. ensuring an equitable distribution of ABT engines. Next slide. These pie charts show a comparison of the percentages of annual sales for ABT engines reported in California versus nationwide. As previously concluded by CSER, there is no reliable method of tracking the number of ABT engines being distributed among the 50 states. Therefore, the data used to create these pie charts must be considered limited. Furthermore, the pie charts do not differentiate between ABT engines with more stringent family emission limits, FEL for short, versus those with less stringent FELs. Based on the data we do have, it appears that California is receiving more than the national average of ABT engines at 5.16% versus 1.25% nationally. This could be a good thing or a bad thing, depending on whether the FELs of the 5.16% ABT engines are lower or higher than the Tier 4 standards. However, even if the California FELs are split evenly at 2.58% between higher and lower emission levels, California would still be getting more than its fair share of less clean engines than the national total of ABT engines. Next slide, please. Staff will be answering questions a little later in the workshop. But if you aren't able to ask your question today or receive answers to your questions due to time constraints, or should you think of questions after the workshop, please email the Tier 5 team at TIER5@arb.ca.gov. That's tier5@arb.ca.gov. The email address will be provided again during Ms. Jenna Latt's discussion of next steps regarding the Tier 5 regulatory development process at the end of the workshop. Staff requests your comments on today's presentation, and we especially request any data that you would like to share with us regarding off-road diesel activity and emissions performance. In particular, we request data that will help in the development of an off-road low-load certification cycle and in the development of off-road hybrid powertrain certification procedures. Please mark information as confidential or proprietary that you do not want to be shared publicly, taking note of the disclaimer at the bottom of this slide. This concludes my presentation. Thank you for your very courteous attention. Now back to you, Christian.
Well, thank you, Jeff. Our next presenter will be Chris Sharp from the Southwest Research Institute. 1 second while I change the slides over. Yeah.
And just as a reminder, for today's agenda, we do have several blocks of time set aside for fielding questions. So thanks so much to those of you that have been entering questions into the Q&A. We will plan on answering all of those verbally during that session. So just sit tight, we're not ignoring you.
And also continue to ask questions.
Yes.
One second, share screen. Here we are. Oh.
Maybe while Christian is working on that, I can take one of the first questions, just so we're not waiting. A couple folks asked about cost, and have we quantified cost yet for this proposed measure? And I just wanted to note that we are at the very beginning of this rulemaking process, so we definitely will be quantifying, estimating cost, both for whatever we end up proposing and for alternatives to that, and we will be quantifying cost effectiveness, but we are not at that point yet. But if anyone has data that they think would be relevant to helping us accurately estimate cost, then we very much encourage you to share that with us. Are folks seeing the slides or not yet?
Not yet.
Okay, why don't we take some questions while Christian is working that out?
Christian, also, I think I could screen share if you're unable to get it going, just let me know.
Why don't you try, Chris?
Yeah,
Okay,
sure. Can you try, Chris? Thank
let
you.
me give that a shot. Oh, it let me do it before and now says, oh, there we go.
There we go. We see him.
Okay, hopefully, let me just change this display real quick.
Okay, and I'll take one more while Chris is working that out. So Joe Campbell at 920 asked, are Tier 5 standards being implemented by manufacturers yet? And the answer to that is no. It's currently what we call the Tier 4 standards, are those that are in effect, and manufacturers have to comply with those to legally sell engines. And what we're talking about here is what should the next tier be? And then once we've developed that and it's gone through the whole official rulemaking process and there's been lead time, then manufacturers would be required to meet the Tier 5 standard. So this is just the beginnings of a proposal. Chris, want to take it?
Okay, ready when you guys are.
Yeah, go ahead.
Alrighty, well, thanks everyone, and good morning, or in some cases, possibly good afternoon. The objective for this presentation today is to give you guys an overview of the ongoing non-road low NOx demonstration program that's happening at Southwest Research. That's actually been going on since about a year ago and more. Just to give you a sense for, what's the structure of the program, where we are at this point, where we're going, and maybe a little bit of data along the way. So in terms of the actual program and its objectives, the base objectives of the program, as has already been mentioned, we were asked to target a NOx reduction of 90% from the existing Tier 4 standards. So in the range between 56 and 560 kilowatts, that means our nominal target is 0.04 grams per kilowatt hour and PM reductions of 75% or a 0.005 gram per kilowatt hour target level. So those were the overall goals of our technology demonstration. We do expect incorporation of current PM filter technology. And of course, there are a number of non-road engines that already have PM filters, DPFs, as part of their certified packages. And so it's, we fully expect that will be part of the technology mix that we demonstrate. And so at the end of the day, in fact, the engine we're starting with already has a DPF on it, although we'll be using an updated and somewhat more advanced version of that. And so really, primarily, this development effort is really going to center on NOx reduction, because the PM filter will allow us to achieve emission levels that are well below that target already. And that's a demonstrated technology that's already out there. So really our focus in the program developments is going to be on NOx. And with the completion of all the various contracts that feed into this, we'll be investigating a number of different technology packages. And ultimately, because these standards have to be met at end of life, we will be doing a final demonstration on a down-selected technology package where we do full aging on engine using accelerated methodology to a 12,000 hour equivalent useful life level. And the final demonstrations will be conducted at that point. So those were our primary goals with respect to criteria pollutants. However, there were some additional considerations as far as the objectives are concerned. Within the original program, we didn't actually have an explicit greenhouse gas target. And so the minimum objective that we took from that was that we should be at the minimum greenhouse gas neutral. So we didn't want to change fuel consumption in any way in terms of a negative impact, as well as making sure there were no increases in either N2O or methane emissions from the base engine. Whether or not we seek GHG reductions does impact the demand for technology as part of the technology demonstration. And there were some continued discussions following the initial contract issue, and CARB subsequently did indicate a need to address GHG reductions, and I'll discuss the targets in a minute. So a greenhouse gas reduction target was also added to the program, and I'll show kind of how we shifted the scope a little bit in response to that. There are some other considerations that we have, which when we start, when we want to talk about things like feasibility, though, that are not necessarily defined within in some of the scoping statements, but they're considerations that we have to account for when we're trying to come up with technology. We do have to consider being able to fit it on machines. Non-road machines are generally much more varied than the situations that we see in on-highway, and so packaging can often be somewhat more constrained. And as we look at trying to translate technologies that we might have utilized in the on-highway demonstration programs previously, we have to consider this stuff. Additionally, we do have to worry about cost constraints. We don't have an explicit target, but we have to be sensitive to cost as we pick our technology choices. We do need to recognize that in the off-highway market, there is some more cost constraint in cases. And one of the reasons for that is in a lot of on-highway, especially heavy-duty engines, there is an opportunity to use fuel savings, if we can come up with them, to pay for, if you will, technology. But there's not as much fuel consumption in the non-road market generally, and so it's much more difficult to do that kind of thing. And so in that sense, we may be somewhat more sensitive to first cost than we might be in an on-highway situation, as well as the fact that we just have a much wider variety of sizes and applications that we have to deal with. And so that means that any cost associated with development is a little harder to recoup through economies of scale. And so we want to consider these kinds of factors as we consider what technologies we want to utilize in our final package. As I mentioned before, CARB did come back to us and add a greenhouse gas reduction target to that. And that target is to look for between 5 and about almost 9% reduction from our baseline engine. And for those wondering where that that combination of numbers comes from, it is a similar amount of reduction that was asked for by the phase 1 greenhouse gas standards in the on-highway sector. And so that's the basis behind those numbers. And so if we look at pursuing greenhouse gas reductions in addition to NOx reductions, that does change the demand for technology. And so ultimately, the original plan actually looked for us to put together 2 packages, and we leveraged that to try to meet the targets of the program. So we've split the demonstration into 2 different packages that we'll look at least from an initial standpoint. A first package, which we've dubbed as the lower cost package, we'll be looking at the initial targets of the program, which were to meet NOx reduction targets at essentially a GHG neutral package. While package 2, as we refer to it, or the low greenhouse gas package, will be targeting meeting both the NOx target and the targeted greenhouse gas reduction between 5 and 9%. And that package will require some additional engine hardware levers to help us enable success. And again, that's really that additional technology pull that meeting both NOx and greenhouse gas targets will bring into play. So that covers the program targets. Here's our demonstration engine. This is a John Deere 6068. It's a 6.8 liter diesel engine, fully compliant with Tier 4 standards as it stands right now, at about a 100, just a hair under 190 kilowatt nominal power rating. And this is an engine that goes in a very wide variety of applications across power generation, agricultural applications, construction equipment. So it's a pretty broadly applied engine in a number of areas. The engine does come normally now in meeting Tier 4 standards with a DOC DPF SCR aftertreatment system. And so there is a base aftertreatment system that goes with this to help it reach Tier 4 standards. We'll talk about baseline emissions in just a little bit. Of course, that aftertreatment system will be replaced by a more advanced aftertreatment system as we look toward meeting the program targets. So this is our program target engine. In terms of duty cycles for the program, they will be the non-road duty cycles. So the non-road transient cycle, which features both a cold and a hot start test, although the cold start is weighted much less than the comparison for the on-highway engine. So that's something to keep in mind. And then the ramp modal cycles for either variable or constant speed engines of the C1 and or D2. We are going to use the C1 cycle for this program. So for variable speed engines, it does encompass a wider range of speed and load targets. So that's the one that we'll be choosing for this engine. And finally, a low load cycle. And as has been mentioned previously, there is no official low load cycle right now. And at present, the development of such a cycle is not in the current program scope for demonstration. But we do have what's been referred to previously as the low load application cycle, which was actually developed for the initial phase of this program, a baseline effort that was presented a few months ago at one of the research seminars under the contract number that you see. And so we will be using the low load application cycle, or LLAC, as our low load cycle, pending the availability of an official cycle that could possibly come later. So for all practical purposes, the LLAC will be our low load cycle. And just to talk about that cycle a little bit more, it was developed based on a variety of real world application cycles that were available from John Deere, who is serving as our OEM partner for this program. And we very much appreciate their support in a wide variety of areas. And we can't really share the input data sets because these are proprietary cycles, but they represent a variety of more challenging applications available with data sets provided to us. And so we basically worked our way through those data sets and ultimately came up with a composite cycle representing a variety of applications that looked to be somewhat lower load at the lower end of the load range based on the data that we were given, but still representative challenges that we would see. And we worked together with Deere to come up with a representative combination of these. Here is what the low load cycle actually looks like. As you can see from the labeling and annotations, it is actually a combination of representative pieces of operation from 4 different applications and does cover both construction and agricultural applications, as you see here. So this is what it actually looks like. The cycle actually is on the order of about 4,400 seconds long. And on average, it lands at about 15% of maximum engine power. This is just looking at the normalized cycle in one of those formats. And you can see quite a bit of different operation here. There is some very intermittent kind of sustained stuff where we're cycling to high and low load fairly rapidly. There is some very sustained light load applications, some PTO stuff going on here. There is a little bit of road transport. So there's a small section of motoring, which is uncommon, but not unheard of within non-road applications. And finally, an application that is alternating between idle and some bursts of higher load for short durations. So each of these represents a different kind of challenge associated with low load. Just to give a sense for the non-road cycles in general, this is a comparison between on-highway cycles and non-road cycles. And in terms of where the load factor tends to fall. And as you look at these, what you'll see is that generally in the non-road sector, the average load factor for these various cycles is somewhat higher. And that's true across the board. So you'll see that in the transient cycle, where the NRTC is somewhat higher load than the FTP, through the RMC, the steady state cycles. And the low load application cycle in the end follows a somewhat similar trend. So that cycle is quite a bit lower than the current certification cycles in the transient and steady state, but still it is somewhat higher than the on-road low load cycle is as well. And so that trend does sort of stay consistent across the board between on-highway and on-road. So here's our baseline engine NOx emissions. I think Jeff may have showed a copy of this as well. When we look at the current cycles, so the NRTC and the ramp modal cycles, either one that you pick, the current standard, NOx standard for this engine is 0.4. And so as you can see, we are well below that numbers. And keep in mind, the baseline testing was conducted on degreened after treatment, so it is not yet aged to full useful life. We would expect those numbers to increase with aging, but still, we are well below the current standard. A fairly comfortable compliance margin with plenty of room to deal with some of the issues that may crop up. And this is the kind of performance we would expect for a fully Tier 4 compliant engine. And from what we've seen on some of the off-cycle stuff, we don't see any issues with NTE. So the base engine is fully in line with expectations as far as a Tier 4 final engine is concerned. But when we look at the low load application cycle, we get a little bit of a different story. There, the emission controls aren't working nearly as well. Keep in mind that the LLAC is, as I mentioned, as shown previously, well below the envelope of any of the current certification requirements. And in fact, it is also almost entirely below the NTE range as well. So the LLAC really is outside of the scope of the current certification. And that's why we're part of the reason that we're examining that to kind of look at, what can be done to close that low load emissions gap in a manner similar to what was done for the on-highway program. So if we look at data, a little bit of continuous data and zoom in a little bit more, this is what we look like this is actually a hot NRTC. You'll see that by and large, engine out emissions in blue and tailpipe in black. Toward the bottom, you'll see that by and large, we have very good emissions control, other than early on, shortly after the start, where we're still kind of warming things back up. And so that gives us about a 0.08. This will have to come down considerably for a hot start. In a low NOx sense, we'll essentially have to create what looks almost like a flat line on the bottom at very nearly nothing. Maybe a couple early wiggles will be it. So that's what we look like on a certificate current cert cycle. Things are looking pretty good. Not so much when we get to a low load cycle that is below the current requirement. You can see here, our temperatures are much, much lower. We spend a lot of time hovering around 200 degrees C on the after treatment, going below it. And you can see that now we're seeing bursts of emissions coming through whenever the after treatment is cooling off. Sometimes we get complete, loss of control at the bottom or during idle. And then we get return to service events where we have, emissions that are coming out. And this is the kind of thing, again, that we see characteristic for low load operation when we're operating outside of the current requirements, which is really where this is. So I think this kind of information indicates that our low load application cycle really would challenge, a lot of the current equipment. And there's some more data on that in the previous program that's been presented. And so a lot of our task is going to be about seeing what we can do to both improve this temperature situation and improve the performance at low temperature of the after treatment system so that we can get emissions that look nice and flat like this across the board, even at low load. So that'll be part of our calibration task in improving this performance from 67% conversion into the high 90s where everything else belongs in terms of NOx conversion. So plenty to do. Here's the overall program timeline. And as you can see, we're well on our way in this one. There's been a lot of initial preparation effort happening really over the last year in terms of system design and the engine baselining, some initial engine calibration work. And of course, we also have to procure all of our after treatment systems. That period of time is just about done. And we are starting to see some of our after treatment hardware arrive now. In the meantime, we've been doing a lot of work on greenhouse gas technologies and engine technologies, and I'll show you just a little bit of data from some of those options today. And now that the after treatment is arriving, and as we get toward the end of our engine-based work, we're going to start marrying the after treatment system onto the engine late this year and really proceed forward into that next level of integration and engine calibration through about the first half of next year. We'll demonstrate both target packages in probably early in the second quarter of next year, down select one of them to carry forward and complete all our calibrations by mid-year. And then roll into our final aging and demonstration, where we'll be doing a simulated 12,000 hours of durability. We will actually stop and test at 8,000 hours, which is the current requirement as well, and then do an extended run to reach 12,000 hours. And as I mentioned, that work will be done on engine using the DAC protocol, the diesel accelerated aftertreatment aging cycles protocol that was used in the on-highway demonstration. So we will be leveraging both thermal and chemical demonstration, durability rather, in a realistic fashion. And that's kind of how the whole program is going to lay out. So as we get into the late part of next year, we should be completing the demo and getting into reporting. As of right now, our initial engine calibration is completed until we, so we've made some preparations for the aftertreatment based on simulations and performance expectations. We'll continue that calibration once we put on the aftertreatment systems. We are currently working with cylinder deactivation. That effort's nearing completion. We'll be looking at dynamic skip fire as an expansion of cylinder deactivation at the use of an EGR cooler bypass and some other hardware levers as well. And as I mentioned, the first of our aftertreatment systems are now arriving and we're preparing for aging. So we're really getting into the real meat of the program now, and we expect probably within about the next 4 to 6 months, we're going to start seeing the emergence of real integrated results and looking at what we can really achieve in a feasible fashion. We need to talk a little bit about program targets. And so that's what I'm discussing a little bit here. So these are some of the calculations that were used to develop the targets that were given to our aftertreatment partners for system design. They don't necessarily represent, we get here and we're done. We actually intend to achieve the best performance that we can. But the calculations were based around having about a 25% margin. In this case, it's about 20 to 25 in these projections to the standard at the end of life. So after we've accounted for aging and degradation, we still need some margin to the standard to account for production and all the things that we don't anticipate in the laboratory demonstration. And so needing that kind of margin, we back out through how much we allow for degradation. We've looked at about a 0.5% loss of conversion performance on the aftertreatment, and we've chosen those numbers based on the experience that we had in the on-highway program. So we want to anticipate similar levels of degradation that we've seen within that. And that's what these numbers are based on. So about 0.5%, or on the low load cycle where performance loss is maybe a little bit more severe, about a 1% loss of conversion performance. And in backing all those numbers down, we get to these new targets that basically tell us what we have to try to achieve with a D-green system in order to have a chance to get to this kind of level at the end of life. Some folks, from our opinion, we would generally consider this to be kind of a bare minimum of getting it done in terms of having that kind of margin. There has been some feedback that we need a larger margin to the standard. We'll be considering that during the development. And again, we're going to try to target as much as we can. So if we can get a larger margin to the standard, we will. And we'll be presenting some of those different choices and how that impacts the overall package as we move our way through development. So this is the package one stuff. And again, our goal here is to meet NOx targets and stay greenhouse gas neutral. When we talk about the second package, where we also want greenhouse gas reductions, from the standpoint of the aftertreatment, the primary impact that's likely to have on us is that we're probably going to have to increase engine out NOx levels somewhat over the base engine as part of reaching that reduction in greenhouse gas emissions. So based on our initial simulations, we're looking at projecting a 30 to 45% increase in engine out NOx. And so we have to consider that. And what that does to the aftertreatment really is it means that we have to increase the performance demand on the aftertreatment. And that increased demand in turn is what creates the pull for additional technology levers, such as things like cylinder deactivation, other heating, technologies, that sort of thing. And so, ultimately, as we back through similar calculations, we're still going to have to suffer some after-treatment degradation. We have a little bit less room for it in a couple of spots. And as we back up through this, you'll notice that our performance targets now versus where they were on the previous slide are lower. So we have to reach lower levels in order to accommodate this increase in engine out NOx, and that leads to a higher demand for conversion efficiency, which in turn creates that draw for more technology. So those are, again, these are our initial design targets that we worked with, but we will be looking to create as much margin as we can as we incorporate technology. So with that in mind, here's a list of some engine technology and other technology levers that we're looking at. In addition to some of the other after treatment, we are looking at cylinder deactivation. Jacobs Vehicle Systems has provided us with a CDA system I'll show you in a minute. We're looking at incorporating dynamic skip fire, which is an advanced control methodology for cylinder deactivation to leverage the most we can out of that technology. We are looking at some heated mixer and e-heater technology for the after treatment system. We are working on incorporating an EGR cooler bypass and larger leveraging of the intake throttle. So these are a number of hardware levers that we are working with on the engine, in addition to all of the existing hardware and flexibility that's on the engine with its existing EGR technology, leveraging multiple injections, and all of the other engine calibration modifications that we can also make use of. I'll show you a little bit of the use of some of that calibration a little bit later in the presentation. So here's an example of some of that hardware. This is actually a cylinder deactivation system. You can see it here installed on the engine. This is a picture of the cylinder head, and you can see the individual valves and bridge assemblies that are being used on the engine. So to actually deactivate valves, when we do cylinder deactivation, we have to both turn off fueling, but to maximize benefits, we actually want to turn off the valves for a given cylinder when it's deactivated, so that we're no longer breathing air and suffering all those pumping losses. And that lets us maximize our fuel economy benefit, as well as some significant improvements from the standpoint of thermal management. So CDA at light load can help us to both manage temperature and improve CO2 at the same time, which really makes it a powerful technology to leverage. So this is what that hardware actually looks like installed on the engine. This is just an example of how we might use it. This is one of our initial map-based approaches. So different numbers of cylinders firing at different speeds and loads. This is kind of what that control might look like in one of the particular modes. And you'll see that in different loads and at different speeds, we'll choose different combinations of cylinders. And this is all developed keeping in mind both the emissions performance that we want, but also being sensitive to vibration, because cylinder deactivation, if it's not implemented correctly, could cause vibration issues. And so it's very important when you integrate this technology into an engine that you also consider where you can and cannot run certain combinations, so that we wind up with acceptable vibration characteristics, so we're not breaking stuff on the engine. So there's an example of how that comes out. And just looking at some actual data points here, these charts are essentially showing exhaust temperatures on the x-axis in all these charts versus other parameters such as CO2, NOx, and these are all shown soot rates. And generally what we see, and they're different combinations of deactivated cylinders versus a base engine. The general trend that we see is as we deactivate cylinders up to a point, we will see, and of course these are at different speeds, that we generally have improvements across the board in CO2, as well as increases in temperature. We do get decreased exhaust flow rates. That can help us out also in terms of thermal management on the after treatment system and maintaining heat. There are cases where if you're not firing enough cylinders, things turn a little bit ugly. And so there are cases where we are not able to run certain modes and they're not necessarily beneficial. This is at about a 2-bar load, which is getting to the range where you'll notice things often look ugly with 2 cylinders. So we don't use those at these higher loads, where at light load, it might still help us. But firing 3 or 4 cylinders instead of 6 provides us with improved performance, lower CO2, we can actually help ourselves out on NOx emissions if we need to. And we can still keep soot under control, sometimes improve it. So that's the kind of flexibility that we can get with a technology like CDA. We'll be incorporating that and seeing, does this provide significant, a sufficient benefit to justify its on costs and development when in terms of putting it on as part of the final solution. So there's an example of some beneficial technology. Here's another little bit of result from this, from an EGR cooler bypass. You've seen some significant quantities of idle under certain cases. Incorporating something fairly simple like bypassing an EGR cooler allows us to use EGR more freely at idle without risks of things like condensation and other problems that normally would prevent its use in the field. So we can leverage it for reductions in NOx, and we can get very substantial reductions in NOx, as you see, as well as actually improving fuel consumption a little bit at the same time due to some reduced pumping losses. We can cut down exhaust flow rates to some extent, quite a bit, as you see, which again helps us preserve heat in the aftertreatment system. So another technology that can be leveraged under the right conditions to help us both improve fuel consumption and reduce NOx emissions as well. So these are the kinds of technology levers that we're looking at incorporating as we start talking about that package 2 target with a CO2 reduction target as well. Although all these would remain available to use if we need them in package 1, but let's recall that in package 1, our target is to try to hit, our goal is to hit the NOx reduction targets at the lowest cost that we can. So we don't want to incorporate technologies unless we need them under that case. So I mentioned before a little bit about initial engine calibrations. Before we start adding too much other hardware, we wanted to look at our range of flexibilities with the engine itself. We've been given different emission targets, lower load emission targets that weren't there in tier 4, and we need to explore the flexibility of the engine itself to reach toward those targets. In the case of package 1, we need a little bit of help based on our simulation work with the aftertreatment to change temperatures and help us in a few key areas, but we want to make sure that we can do that in a way that has a net zero impact on CO2. And then for package 2, we also want to explore just how much we can improve CO2 by making changes to the engine calibration, and how does that impact engine out NOx and the demand for NOx reduction coming. So we did a bunch of calibration work to explore that, and I won't go through that in too much depth in the interest of time, but I'll just show a couple of examples of how we might leverage engine calibration. So for instance, this is the cold start non-road transient cycle. Of course, we need to warm up more quickly here. And so the black is our baseline, the red and blue are actually our modified calibrations. And you'll see us doing things like increasing temperature early on. This is only the first 400 seconds of a 1200 second test, so about the first third of it when we're still cold. And you can see that we do want a little bit of help pushing up temperatures early on to help maximize the warm up of the engine and aftertreatment system, and help improve the performance of our advanced aftertreatment when it shows up. So a little bit of temperature bump is still helpful. And at the same time, while the aftertreatment's not warm, we want to lower engine out NOx early on, but we're actually free to increase it later. So for something like even a package 2, we might increase engine out NOx substantially. And that's okay when we have a warmed up aftertreatment system, because we can control tailpipe NOx levels, which is the real goal. And by increasing that NOx later on, once the aftertreatment can take it, we can have an improvement as far as CO2 emissions. So all these changes can be done in at least a CO2 neutral fashion. And in some cases, we can get some benefit as well. For the low load cycle, we mentioned before about the issues that we saw on the base engine controlling on that one. So here again, we need to make some improvements. We will have advanced aftertreatment systems. They will be capable of more conversion at lower temperatures, but even still, looking ahead at performance, we're still seeing temperatures up on the top right here. You see the SCR temperatures. We're still dropping below 200 degrees C and below 220 in cases. And that's not really as optimal even for the advanced systems. So we're already looking at improving performance based on some of our initial simulation work to help the aftertreatment system really maximize conversion. But the good news is, again, we can do this in a fashion that really doesn't have much of an impact on CO2. And again, keep in mind, this is just with the base engine. We can, for instance, at these some of these very low load and idle points, get benefit from that EGR cooler bypass stuff that I showed before. And of course, on these light loads especially, this is a place where stuff like cylinder deactivation can really make things look a lot better. So just a couple of examples of some of the modified calibrations. And really, this is a start point for us as we include aftertreatment and then work on calibrating the combined and unified system. So speaking of aftertreatment packages, here's a couple of examples of some of the aftertreatment packages that we're looking for. So here's one of the concepts for package one. The current aftertreatment system on the engine is actually a 2-can package with an 11-inch diameter SCR and a 9.5-inch diameter DOC DPF assembly with a transfer pipe between them. So this is a more up-to-date concept. It's a little bit bigger in diameter at 12 inches instead of 11, but is a single module type approach. So all of the aftertreatment systems are incorporated into a single can. We still have the DOC, DPF, the integrated compact mixer with DEF dosing, and the downstream SCR catalysts. And really for the 12,000 hour packaging, there's an extra module that's likely to be added to this for either 12,000 hour durability or package 2, depending on what we find in development. And another example from another supplier of some different aftertreatment setups. You'll notice still that sort of single module architecture here. It could be split for packaging on certain machines. Again, there's some non-road machines that have different requirements in packaging. But for the demonstration system, we're doing a single module system. Again, a DOC and a DPF arrangement with a mixer in between and downstream SCR after that. The DEF dosing is here. And then it's possible under package 2, we may need more NOx reduction yet. We may need to kind of leverage more low load technology. The architectures we've been looking at are still somewhat similar in concept to the DOC, DPF, SCR, the base engine. But it's possible we'll need more than that, especially for package 2. And so we're looking also at concepts that allow us to use a light off SCR, this catalyst assembly here. So we've removed the conventional front end and added a different one. This is actually, this catalyst here is actually called a multifunction catalyst, and incorporates both light off SCR functions, similar to what we're looking at in the on-highway world, but also some in situ oxidation that would allow it to maybe be a little more robust in the face of things like post-injection for regeneration. We also don't need quite as much from the light off SCR in this non-road space as we do from the on-highway engine. And so we can afford a little bit of compromise on that setup. And since this actually has some oxidation function, we can pair that for packaging with a zoned catalyzed DPF rather than an explicit DOC here, while the downstream part of the SCR remains the same. If we go with light off SCR, that also means that we have to go with dual dosing. So we would incorporate an upstream doser, and we actually have options to either use conventional DEF or even a heated doser. We could, in fact, also incorporate the heated doser on one of these simpler packages, all as a way to try to extend low load performance. So we have a lot of different options and things to look at. One thing you'll notice, though, even from our work here, if we are incorporating light off SCR, we're projecting that we would still incorporate it only really in an underfloor type of location. So the close coupled light off SCR options that we're looking at in the on-highway world, we don't think those will be necessary here, even if we do have to go to a dual SCR, dual dosing kind of arrangement. So that's just a look at some of the after-treatment options that we're looking at. And of course, that will be paired with our advanced model-based control architectures. A lot of this control technology was developed for the on-highway demonstration, but we intend to bring that in here. So the advanced model-based controls incorporate feedback systems, both high-speed feedback with a mid-bed ammonia sensor if we need that, as well as long-term trim via a tailpipe NOx sensor. So this is the kind of advanced control that we'll be bringing to the table to help us reach our targets and maintain that performance over time. So that's a bit of a look at what the program is going to look like. We can, of course, take questions in the Q&A session a little bit later. And with that, I guess I'll turn the floor back over. Thanks everyone for your attention.
Thank you, Chris, for your presentation. Now we'll get into our question section. I'll put up some information for those who want to ask a question.
Okay, while you're doing that, Christian, we can just start off with the questions. So I can read them off while you're trying to pull that up from the Q&A box that we got already, and then we can transition. So the first question was from an anonymous attendee, and the question was, can you comment on how the emission inventory would change if all off-road equipment in California was Tier 4? What is the incremental inventory reduction expected from Tier 5 versus Tier 4? And Dr. Liu will take this one.
Yeah, so thank you for the question. So definitely replacing all existing Tier 0 to Tier 2 and Tier 3 equipment will have a huge impact in the emission reduction. Actually, in the mobile source strategy, I don't know whether you heard of it, we have run different scenarios. One of it is like replacing all construction equipment from Tier 0 to Tier 2 to all Tier 4 final. And it has a pretty big impact in emission reduction, especially in the near term. But as we mentioned before, Tier 5 is only part of all the comprehensive emission reduction measures to reduce emissions in the state of California, right? We need all the emission reductions we can to achieve that 70% reduction. So we need to get rid of the Tier 0 and Tier 2, the old ones, and also enforce new standard to reduce emissions from the when they are replaced, so they can conform to Tier 5 instead of Tier 4. So I hope that answers your question. And also for the construction equipment, I think they have their own workshop if you were looking to see the actual regulatory proposal for replacing the older equipment in the sector, and the emission reductions is all presented out too.
Right, and that is what you're referring to is the off-road in-use fleet or diesel fleet regulation or rulemaking process that's undergoing right now. They've had many workshops, they've had many working groups as well, and so you can check that online on the CARB website. Yeah,
so that will cover replacing the older equipment. And enforcing Tier 5 would definitely have a bigger impact in the longer term, like when all the old equipment have already been replaced through retirement order rule. So that's also another part of it.
Thank you. All right, for the second question, is the emission factor determined by the engine manufacturer or by the state?
So CARB and EPA sets the emission standard, and engine manufacturers are supposed to manufacture the engines with emission factor that meets the emission standard. Okay, so we will test the emission factor for each engines manufactured by different manufacturers. So the emission factor of that specific engine will depend on the engine manufacturer, but they are supposed to meet the state standard.
Okay.
I hope that answers the question.
Great, thank you. All right, the next is from Danan Du. your last name is D-O-U. I apologize if I mispronounced it. The question is, off-road engines have reduced emissions in 2011 and 2014 through IT4 and FT4. Does California off-road emission contribution data against on-road suggest that older in-service off-road vehicles are making up the bulk of the emission inventory? In other words, does taking off old off-road vehicles be more effective to make a bigger impact to the emission inventory?
So I guess this is similar to the first question. Like I mentioned, they are, I mean, replacing the older vehicle, replacing the old engines, and also enforcing the Tier 5 should both be considered, right, in a comprehensive strategy to reduce emissions from California. Like we need 70% reduction, so we need all the reductions we can get. And in the near term, definitely replacing the older engines with the cleanest engines will have a bigger impact. Like you can see from our scenarios, like by 2030, because Tier 5 won't be implemented until like 2028 something, but by 2050, the most of the emission impacts will be from Tier 5 standard. So I think they are both important, and this workshop mainly covers the Tier 5 standard, the impact.
All right, thank you. The next question is from Tony Stab. If we reduce from 10 tons per day to 5 tons per day, that is significant, but a 50% to 80% reduction of 0.5 tons per day is not significant.
So we're not just looking at 0.5. I think if you see the figure by 2050, we'll actually have 20 ton per day emission reduction from Tier 5 altogether. So that's not insignificant. So like I said, it's also off-road standard is much more lenient compared to on-road heavy duty standard. We are like probably 50 or 70% higher than off-road than on-road heavy duty engine standard. So we definitely have the technology to be cleaner. So why not, right? If we can make the engines cleaner, then we should do it. And Tier 5, I think, and it's already been 7 years since Tier 4 final. I think off-road needs a new standard to achieve all the emission reductions we can.
All right, thank you. Anonymous attendee. Airport ground support equipment, which utilizes a PTO or power takeoff, will operate over 50% of the time at an engine power less than max horsepower of the truck's engine rating. Will they be calculated utilizing the shown formula?
Yes, so load factor is applied to all off-road engines. If you go to our website, we actually have a detailed spreadsheet for off-road emission factors. I can share the link to it. Has the load factor for all the off-road equipment. And I believe for airport support equipment, the load ranges from like 30% to 50%. So like you mentioned, so it is definitely considered.
All right, the next one is from J. Yavel C. Please give the explanation about the NOx credit and SMAD. I'm not sure what SMAD stands for, but maybe you do.
I'm not sure what SMAD stands for either, but the emission credits is basically I think it's an EPA's program that's basically have a series of credits, allows manufacturer to have some flexibility in meeting the standards, so they can accumulate the credits, so they don't have, so they can have a portion of the engines that are manufactured a little bit above the emission standard in a certain time, so they can phase in their so they can meet the standards in like phasing period. I think there are much more detailed information on the EPA document, which I can share in the answer. I can share the link, and feel free to look it up or email us if you want any clarification.
Okay, the next one is by Mr. or Ms. by Robin, and I apologize, I cannot pronounce your first name, so we'll go with that. And the question is, would the Tier 5 equipment comply with upcoming regulation based on the mobile source strategy, or would only serve as a stopgap like Tier 4I or Tier 4 final?
I'll
And
give
that's
this
for
one a
Jeff.
shot, Jenna. Yes, the mobile source strategies plan included a provision for Tier 5. It included the emission levels we're targeting at Southwest Research Institute. Those were put in as placeholder standards for now, because we are not proposing, and we don't have an official proposal at the moment. But those standards, if shown feasible by Southwest Research, could definitely become the standard. So yeah, so Tier 5, as shown in the mobile source strategies plan, would be the same as what we're presenting today.
And I believe Christian's going to take over reading the questions.
Sure. I'm going to take a few questions from the attendees raising their hands. Edward Phillips, you can unmute yourself and ask your question.
Thank you, Christian. My name is Eddie Phillips. I'm with BNSF Railway. And BNSF, like many of the participants today, own equipment in all the off-road categories. So we own cargo handling equipment, refrigerated units, construction type equipment like backhoes and front loaders, and forklifts. The question that was asked earlier in the chat is one that's really important, which is what percentage of the emissions reductions that CARB is seeking is from the older equipment? And it was answered, but not with a number. So by analogy, if you look at the on-road category, CARB has stated that 10% and 11% of the trucks are responsible for 50 and 61% of the emissions with respect to diesel particulate matter and NOx. And so if in this category of equipment, the Tier 0 through Tier 4 interim is responsible for 50 or 60% of the emission reductions, that's going to get, the ban that's proposed under the in-use off-road regulation will get a huge portion of the emission reductions being sought here with this effort. So I think that CARB should at first step quantify the emission reductions that the proposed ban in the off-road, in-use off-road regulation is going to get. And that kind of brings up the main point here, which is that there are many ways to reduce emissions. Tier 5 is one way to do it, but it's not the only way to do it. And then I think we should also frame for this conversation what equipment we're talking about. So with regard to cargo handling equipment, the Advanced Clean Fleets rule that's being proposed by CARB will require conversion of certain off-road equipment to zero emission. For example, yard trucks, which are currently regulated under the cargo handling equipment rule, will be required to be zero emission starting in 2025, and then 100% by, I think, 2031. Same with the refrigerated TRU rule, which is proposing to adopt zero emission standards for the TRUs. Of course, this regulation would have no impact really on stationary engines unless stationary engines were being replaced. Those are the purview of air districts. So you could wait a long time before you get stationary. And then this rule, I don't think that this rule impacts the PERP regulation, portable equipment regulation. If you propose Tier 5 standard, I believe that the PERP effort has stated there will not be a Tier 5 standard for portable engines, but I'm not 100% certain on that. And with regard to my statement that there are many ways to reduce emissions, we have experience with a hybrid technology. Now, one of the presentations proposed or said there was motive power, hybrid motive power for on-road. I'm not aware of any OEM that provides motive power. All the hybrid systems that provide motive power that I've seen for on-road trucks is in third party, it's an aftermarket. But with regard to off-road equipment, we actually own and operate hybrid systems. So just to give you a perspective on the type of emission reductions you can achieve without going to a Tier 5 standard, We own and operate a piece of off-road equipment that the comparable diesel equipment was 1,000 horsepower Tier 4 engine. The new equipment is a 140 horsepower Tier 4 engine married to a 150 kilowatt battery pack. We've reduced our fuel consumption by about 89%, NOx by 98%. If you were to adopt a statewide mandate for renewable diesel, just like CARB did with the ultra low sulfur rule, not regulation by regulation. I know the in-use off-road regulation is proposing to adopt a renewable diesel requirement, but CARB shouldn't do that regulation by regulation. You're going to miss all the other equipment. They should adopt a renewable diesel standard statewide. That's going to get you about 75% reduction in greenhouse gases, which is a lot more than what you're proposing here. It'll also get you an additional approximately 10% reduction in diesel and about 30% reduction in NOx. And then with regard to idling, I mean, the issue with idling standard is there's no way to enforce that. You've got an idling standard now, and Todd Sachs, I feel for Todd Sachs, he doesn't have the enforcement personnel to enforce the regulation now. But when you're talking about idling, you're talking about fuel consumption. So with the hybrid piece of equipment I talked about, the fuel consumption on that 1,000 horsepower engine was about 9 gallons per hour. That new piece of equipment that's got that hybrid system is consuming about 1.2 gallons per hour. So it's about an 8-fold reduction in fuel. So with regard to idling, if you were to go to a hybrid system for this construction equipment, and that's really what we're talking about here is construction equipment, right? Everything else is going to be converted to zero emission, or it isn't under the purview of this regulation or proposed regulation. So I just want you to really pause for a moment and answer the first question in terms of a number. What percentage of the older tiers are responsible for what percentage of emissions with regard to DPM and NOx? And then pause to consider that there are other ways to get these emission reductions. If you have 50% of the emissions caused by tier 0 to tier 2 or tier 4 interim, you really only need another 25%. So how could you get that without going to a tier 5 standard? And those are my comments. I mean, there are a lot of ways to get there. A tier 5 might be one way, but I'm submitting to you that there are other ways to get the emission reductions that you want and that we all want without developing that standard. I'm not saying that the standard should never be developed, but I'm saying if you want to meet the NOx standards for 2023 and 2031, I don't think tier 5 is going to get you there. And I think you're very optimistic to assume the OEMs are going to be able to produce tier 5 engines in 2025. I think it's going to be 2028 or later. And then the phase in, the way that fleets are going to adopt the tier 5 and integrate them in their fleets is going to take another 10, 20 years. So please consider the alternative pathways to reduce the emissions. So I think we'll get the emissions reductions much sooner at a lower cost and won't require a complete redesign of the engines. And my apologies to the engineers at Southwest Research. Thank you.
All right, thank you for your question. You had a lot packed in there, and I think that we'll first have our folks from inventory take a crack. Corey Palmer.
Hello, I'm Corey Palmer, the manager of the inventory section. A lot of good comments there. So I just wanted to clarify, one of the things we're doing is we are looking at each sector. We do quantify how much comes from each tier currently, and we are working with those reg teams on reductions we would see from turnover to cleanest current tier, so tier 4 final. Those will be part of different workshops. There'll probably be one on the in-use sector, so construction, mining, industrial, in the next coming months. So we did look at that first as part of the MSS, as Leong talked through. We looked at the reductions we could see if we just got rid of the older equipment. And honestly, that alone was not enough for California to meet its future targets in 2031 and 2037. So just turning over to tier 4 wasn't enough. So we need further reductions from the off-road sectors.
Corey, can I, I'm sorry.
Sure.
Dr. Liu said the same thing, and I'm just going to put you on the spot here. What is the reduction? What percentage of NOx will you get by going to a tier 4 standard? So there's no tier 0 or tier 4 interim left in the fleets by a date in the future. Is it a 50% reduction in NOx? Is it less? Is it more? Do you actually have the number that you could share with us? Because it's really important to start there, especially given what the end use off-road regulation is proposing, which is exactly that. Ban everything prior to tier 4 final.
So it's going, I don't have one number that I'm going to put out today. It really depends on the sector and how old they are currently. There are some sectors which are fairly new TRUs. They have a very fast turnover. So you get fewer reductions going to existing tier 4 final standards. Then you have construction somewhere in the middle, where I think we get about a 60% reduction or so, or
60.
Yeah, 60% from current. And then we have older ones like agriculture, which they can hold on to tractors for a very long time. That's why we have incentives in that sector. So it really just depends on which one. If you want to reach out on email, I can share the analysis that we did through the MSS. So we did look at different sectors, just replace everything with tier 4. Be happy to share that. I don't have one number that I have in front of me today.
Yeah. Well, I mean, again, that's what we're talking about is construction equipment. I mean, zero emission forklifts is getting carved out. The in-use off-road regulation is going to implement a ban. The ACF is going to require zero emission for certain types of cargo handling equipment. You're really scaling down the universe or the fleet of equipment we're talking about with this standard to construction equipment and possibly agricultural equipment. So it's really important if you're saying construction equipment gets a 60% reduction and you need 75%, you're talking about a delta of 15%. So, and I don't know what the agriculture is, but I would really appreciate, Corey, and I think everyone else would appreciate, is the next time you do a webinar on this issue to have those numbers broken out by category or industry, because we're really starting with that reduction if the off-road regulation is going to ban the older tiers, as opposed to starting with the status quo today. Because lots of fleets in the off-road category have tier 0, tier 1, tier 2 still left in their fleet. They're still meeting fleet average requirements under the off-road regulation. So sorry to put you on the spot, man, but it really is an important point for us to all start on the same page here. Thank you.
And I think we'll ask you to follow up with us just separately so we can provide that detail, but it was a good suggestion. One thing I'll clarify though, is the 75% reduction is beyond the tier 4 final standard. So it's not from where we are today, reducing that by 75%. It's 75% cleaner than the current tier 4 final standard. That's not a final number. That was just our initial assessment in the MSS. So if you wouldn't mind, maybe just either in the Q&A, just making sure that we have your email, we can definitely follow up. But I thought there were a lot of good ideas in there. So I think I'll pass it back unless somebody wants to add anything.
Well, I wanted to chime in too. I think that was Mr. Phillips talking, and it sounds like you've got a lot of great suggestions, and we would love to speak to you one-on-one and hear some more of those. So please, if you could put your contact information in the Q&A, we'll reach out to you separately. And then in particular, I'd love to hear more about the hybrid and the hybrid device that you mentioned had been effective for you. Thank you.
I think we'll move on to the next question from Manuel Cunha. If Manuel, you can unmute yourself.
Yeah, can you hear me okay?
I can hear you.
Great. Mr. Corey or Palmer, let's give a little credit to agriculture, please. We've done over 14,000 zeros into tier 3s and 4s, tier 4 finals out of the San Joaquin Valley. And that's a huge amount of reductions that CARB has taken credit for. So let's don't forget about saying that ag hasn't done anything, because you didn't say that, but you certainly made it sound like agriculture is out there and hasn't really done anything. So let's give some credit, young man, where is deserved, because we've done one hell of a job with the farmer program. and the reduction of agricultural equipment cleaner from our spray rigs to our well pumps, engines, to electrification. So agriculture has done a tremendous job, I think, in getting to Tier 4 finals and continuing with the farmer program, as Michelle and Lucina and their team have worked very hard in working with us with the San Joaquin Valley. So, but I think on my question is going to be for the on-road, because we have farmers that have trucks. We have farmers that have trucks that haul from the field to the packing house. They're not going to run at the top speeds. There's no way. Our spray rigs are not going to run PTOs at top high loads when you're turning on the end of a field and you shut your rig off and following other rules and regulations, of course. So I think in this discussion of Tier 5 and those costs and all these devices, and I appreciate the research side of saying that these package 1 and package 2 seem like about 48 inches long. And where do you throw that under the hood? How do you put that in there, and what those costs are going to be, and the repairs and the maintenance, all of that has to be looked at. And then the last thing is, who affords to buy and can afford to buy all these new trucks and tractors when they've already invested into a Tier 4 truck that cost them $300,000? And before we know what an electric's going to cost. And I'd like to know where the money's going to come from that, because the independent truckers are a very integral part of this. And we can see the damage at the ports because of regulations on engines and what goes into the port and comes out of the port. We have these ships sitting out in the ocean because of regulations. And I don't hear anybody worried about that at all, other than blaming it on that we don't have enough truck drivers. No, we don't have enough trucks because of the regulations and the situations that we're in. But I do want to emphasize, Mr. Corey, and to everybody else from ARB, is that agriculture has and is doing its part on its tractors and rigs and all that. And we don't get one bit of credit. We don't get one statement said that ag has done anything. It's like agriculture is just not responding at all. And damn well we are. And working with our engine manufacturers and getting the Tier 4s out there, getting rid of Tier 0s and Tier 1s. It's a lot. And the way the farming industry is going and the situation of water and how we produce our food. So if you people want food in this country, or if you want to bring it in with a container that's going to sit out in the ocean anyway from other third world countries, fine. But I do know our farmers are going to eat the food they grow, and they're not going to allow to bring food in on their farms from other countries. So I just want to make that comment. I understand the complexities of this Tier 5, but the cost, and we've already spent a hell of a lot of money. And I think we got to be cautious about that. But let's give some credit. And not one person has said it today from ARB, what agriculture has done. And I'm very disappointed in that from the top end.
So Manuel Cunha, thank you so much for your comments, and we totally hear you. And none of this is intended as a judgment on, on anyone or what they have or haven't done. So we're just talking about engine standards here, and we definitely recognize that you and your members have done and continue to do a lot to try to cut emissions. But there's a lot more comments and questions that we're hoping to get through. So if we could move it along, that would be awesome. Okay, so Christian, who do we have next?
The next question will be from Steve Berry. Steve, you can unmute yourself.
Thank you, Christian. First, thanks to CARB staff for all the comprehensive information prepared today. Appreciate the opportunity to comment and raise questions. A lot of moving parts. We look forward to working with you on this regulation. First, a few comments and then a question. Early in the presentation, Jeff Lowry pointed to the targeted manufacturer rule to go to the board in 2025. That's a pretty short time from now for something as important as zero emissions, non-road equipment requirements being set. We really need to to start talking about this issue, and especially around the suitability of battery electric and other zero emissions technology options. So we look forward to reaching out to you and finding an opportunity, multiple opportunities, obviously, to address that question. It was mentioned that you'd like to get EPA involved for the segments below 175 horsepower. As recently as 2 weeks ago, EMA President Jed Mandel, and excuse me, I'm from the Truck and Engine Manufacturers Association. I should have mentioned that at the outset. But Jed Mandel reached out to the administrator a couple of weeks ago to say that absolutely we would like to see EPA get involved in this space and work with CARB on the non-road regulations. And it goes beyond EPA. China is working on non-road regulations. Harmonization has been an extremely important aspect to this industry. If you've heard us say many times about how heavy-duty trucks are not like cars, there's a much greater degree of diversity in product, and how critical the operation of the vehicle is to the purpose behind its purchase in getting a job done. That's a tenfold issue in the non-road space, with the variety of equipment types, the number of OEMs involved, and the diversity of the specific applications for any given piece of equipment. So harmonization to secure common solutions for equipment to be sold worldwide is extremely important. So yes, we will work with you to get EPA, but hopefully also other parties involved and work toward harmonized regulations to avoid some of the pitfalls that were mentioned also by Jeff, out-of-state purchases and other issues. I appreciate the comments very much from Chris Sharp regarding margin. We've approached the CARB staff with respect to this issue. Without adequate margin to protect for and to be able to achieve the reductions that are necessary over and above that which Southwest Research is charged to demonstrate is extremely important. We'll have to achieve, our manufacturers have to achieve even greater reductions than Chris will have to demonstrate. And that means that can easily mean costs beyond those recorded in the rulemaking record, CO2 impacts recorded well beyond what's recorded in the rulemaking record, and even potentially in feasibility, such as we're potentially facing with the 2027 omnibus requirements. So we really look forward to working with you on that issue, and from very technical perspective, have a really deep discussions on the details behind that analysis. And now my question, we discussed warranty. We know from the highway experience that there can be a lot of discussion around the cost implications of extended warranty requirements. So I hope that we can have a more fruitful discussion before the rulemaking is largely complete in this occasion, and that CARB is committed to identifying the full range of costs that can be incurred by purchasers, not the average cost, so that the board, so that stakeholders can have a complete view of the implications of extended warranty requirements. So we look forward to working with you on that. We hope that alternatives to standard warranty packages can be considered. And I guess a question would be, is CARB looking to engage any consultants to support the cost estimations in this rulemaking? And if so, who do you have in mind?
Thanks, Steve, for your comments and your questions. As usual, you ask really great questions. And there was a lot of there were a lot of comments in there. I want to try to address some of them, even though they were comments. So for the targeted manufacturer rule, I think you asked about that. And right now, as the timeline in the slide showed, we're looking to have a board date in sometime the 2025 timeframe. And so, you know, that group will be setting up workshops, and so look out for that. I think you had another question. Wow, there were so many. Let's see, just your most recent one on warranty. Yes, we will be having we're looking at collecting. We'll be collecting data from a contractor to look at warranty data. We don't have the contract in place, so we can't give you any names. I think you had a couple more things. Do you want to refresh my memory? I think you mentioned about the margin, and we look forward to working with you. As Chris Sharp mentioned, we're shooting for the 20%, and we're trying to look for wiggle room in there. That's not set in stone. So we will work with you on that. And I know that the on-road section is looking at the data that you provided us. Are there other pieces that I missed?
Great. Thank you, Jenna, for those comments. I just also stressed the issue of harmonization and
Oh, yes, the
the importance of
harmonization.
engagement at a global level,
Yes.
not just with EPA.
All right, perfect. Well, I appreciate you mentioning that, especially speaking with EPA. We have been engaging them, and we will continue to do so. And hopefully they're listening right now, or if not, they can download the recorded Zoom meeting afterwards and listening as well. So thank you for those comments, and we encourage other stakeholders to speak with EPA and have them participate in this process. And it's just to remind folks, this is a long-term, multi-year rulemaking process, and we anticipate our board date of 2024-2025 with projected implementation in the 2028-29 timeframe.
Thank you, Jenna. I'll turn the floor over to others who want to ask questions, and I'll put my hand back up again because I have some other questions.
Thank you for being courteous. Why don't we go to the next written question from the Q&A box, Christian?
Sure, that sounds good. The next question is from Mr. Virvan. Sorry if I butcher your name. But the question is, would the Tier 5 equipment comply with upcoming regulation based on the mobile source strategy, or would only serve as a stopgap like the Tier 4I or Tier 4?
I think we answered that, didn't we, Jeff?
We did.
Yeah, so we're on the next one.
Oh, I'm sorry.
No worries.
The next question is from Daniel Carowin. For CARB, there will be exemptions for military tactical vehicles?
And the answer to this is yes. We already have exemptions in the new off-road diesel engine regulations for military tactical vehicles. It's in the application section, 13 CCR 2420. So the answer is yes.
Okay, the next question is from John Gilliland. I thought AQ air quality districts determined that Tier 4F was BACT for prime powered ICEs for both stationary and portable. Please clarify. If not Tier 4F, what is BACT?
Yeah, let me give this a shot as well. When I referred to BACT, best available control technologies, I was talking about the improvements in the DPFs and the enhancements that are being worked on for SCR in particular. I'm not sure about the authority in terms of who declares BACT, but in terms of what's controlling the emissions right now for off-road diesel, that was my intent. And we look at the Europeans, the Euro Stage 5 standards. Their PM standards, I believe, are generally about 50% lower than EPA and ARB standards currently. So obviously better control is available there. The on-road diesel standards that were recently adopted, the heavy-duty omnibus standards, I think they lowered it to the NOx standard to 0.02 grams per horsepower hour, maybe. So again, that's a big decrease compared to what we have for off-road right now. So obviously our standards, the current standards are not based on the best available control technologies. And if you want to think of it even further, zero emission, would be considered a more viable, best available control technology. But that we are talking about engine standards in this rulemaking, this presentation. So what I said about the omnibus and the European standards, I think holds true.
Thanks. The next question is from Patrick Ulenhake. Has financial feasibility been studied for less than 19 kilowatt zero emission equipment?
Yeah, I can take that one. Yeah, so we're going to conduct a comprehensive cost analysis to determine the incremental cost for the Tier 5 rulemaking, which would include, any changes to electrify or zero emission equipment less than 19 kilowatt hours. So we'd appreciate industry sharing any cost or estimated cost impacts early in the rulemaking process. So if you have any data you'd like to share, that would be great. But at this time, we don't have any information. That's part of the rulemaking process right now.
Okay, the next question is from John Gilliland again. Are Tier 5 standards going to be eventually incorporated into CARB stationary and portable regulations? Both these regulations use tier standards. I think Kim would like to answer this.
Yeah, John, thanks for the question. I think that's a question that we can't really answer here. So those that John is referring to different in-use rules that in the past have forced turnover from lower tiers to higher tiers. And so he's trying to look forward and see, oh, well, once there's a Tier 5 standard, would those in-use requirements be updated to reflect the Tier 5 standard? That's certainly a possibility that the CARB folks in charge of those rules could consider, but we don't have an answer on that. And I think others in the chat sort of asked the same question and said that maybe they thought they'd heard from the portable equipment staff that they would not be incorporating the Tier 5 standards. But as far as I know, that's sort of an open question and would be addressed as in the future.
Thanks, Kim. The next question is from Susanna Vona. What load factors are used in your calculations? And I think Liang Lu would answer this question.
Yeah, as I mentioned before, we have an online database that shows all the emission factor, and if you download it, it shows all the load factors for each off-road equipment. I can share the link. Or if you can search off-road diesel equipment emission factors, you might find it too. But I will share the link.
Thank you. The next question is from written question is from Steve Berry. Does CARB have data showing the rebuild hours for non-road equipment? Anything more than industry publications? And I think Jeff would like to answer this.
Hi, Steve. Yeah, thanks for asking that question. We are requesting, as I pointed out in the presentation, we are requesting data from industry and other affected stakeholders regarding this exact question. And we want to know, do we need to extend useful life? Do we need to extend warranty? I know you had addressed that in a separate question as well. So we are looking for information right now. Now, I did mention the industry publications. At least two of them are from members in your organization, where they indicated that, equipment typical rebuild periods are between 12,000 and 15,000 hours. So, we do think that would, if that is true, having a longer useful life period over which the standards need to be maintained will have emission benefits, in use for a longer period of time. But to directly answer your question, no, I haven't seen that data specifically, but I would certainly love to. So please, if you or your members have that data to provide, we would love to see it. Thank you.
Thanks, Jeff. The next question is from Chad Grungle. Aside from the overhaul literature, is there any actual data from in-service applications confirming the need to extend useful life? Does any population even achieve the current useful life?
Yep.
And I think
So,
Jen-
yeah, we're in the process of collecting data right now regarding how long equipment is in use. Warranty periods should be representative of how long equipment remains in use, because longer warranty periods incentivize repairs of emission-related malfunctions for which the manufacturer is liable to repair. We've asked for comments in the Tier 5 presentation regarding the necessity for longer warranty periods. And as well as useful life.
Well, thank you, Jenna. The next question is from Ryan Carls. For engine idling requirements and regulations, can you please define what is considered an idle condition? This might be far different from the definition used than on-road applications definition.
Right now, we're looking for feedback from industry on that. We're requesting comments and data for setting parameters on both a start, stop, idle approach, and looking at an idle standard, as well as test procedures for off-road engines, as well as Southwest Research is planning to demonstrate start, stop, idle technology on the John Deere engine.
Thank you, Jenna. The next question is from Jackson Kwiatkowski. OBD diagnostic software should be provided once warranty expires.
Yeah, hi, Christian. This is Mike Regenfuss, the branch chief of the onboard diagnostics branch. I'll answer that or respond to that comment. I'm not sure that I completely understand the comment, whether it's the question is about the OBD data that can be downloaded from the equipment. But I think it's important to understand, if the OBD information is standardized through this regulation, it means that data would be accessible using a standardized or a generic scan tool throughout the life of the engine, so the owner or operator would be able to access the OBD data during the warranty period and after the warranty period. Access to that data would not require a proprietary dealer level scan tool or diagnostic tool. It would require more of a generic tool that works across all equipment that would meet the off-road OBD standard.
Thank you. And then another question for you is, for now, is OBD being considered for all power categories?
Yeah. At this time, it's not settled. I think we're considering it for all categories that would be covered by the Tier 5 rulemaking. So I think if the commenter has feedback on which categories might or might not be included or excluded, then we'd welcome that feedback with their rationale.
Oh, thanks, Mike. The next question comes from an anonymous attendee. For OBD, is major component monitoring intended to be functional monitoring or emissions threshold monitoring?
Yeah, on that's another one where it's not identified or not decided yet. We want to get feedback on what might be monitored and at what level of deterioration in performance a malfunction should be identified. So it's another area where we're open to feedback.
Thank you.
Christian, since we have so many questions, we're going to try to maybe go through part of the break and see where we get to at the 12 o'clock hour. I know we said that we'd take a break at the at the 11:45 period. But we do want to ask, we do want to answer people's questions as best we can. So, you can maybe, we'll just continue answering questions through the break and see where we get to, or at least stop at noon for a second and figure out where we are.
Okay, that sounds good. We'll continue on with the lightning round here. We have another question from Jack Kwiatkowski. Would OSHA be able to check on-site generators to make sure they are registered? An engine not meeting Tier 5 requirements could be considered a job site hazard due to air pollution.
Yeah, thanks for the question. I think that, that OSHA is its own regulatory agency, so I'm not sure what their requirements are. Of course, they can check, on-site generators, whenever they'd like to. With respect to registered, I'm not sure what you mean by that, because, engines are certified, so that's for sale in California. So that's one piece. And then if they're registered indoors through our in-use program, that's another regulation. So then, our enforcement staff is involved in that. So that's something that you'd have to look at. I think the question went away. And then there's another question. There was another piece. Can you read the second one, Christian? It says, yeah, an engine not meeting tier requirements could be considered a job site hazard due to air pollution. Yes, we understand your concerns.
Okay. Jeff has additional follow-up next. Vendors selling generators could be required to register the generators, putting all their sales in a database. Used engines sold would then be the seller's responsibility to update this account, similar to doors. I guess this is a common.
Okay. Yeah, and again, this is an engine manufacturer's rulemaking process. It's not for fleet, so that would be as part of a fleet rule. Although I know you're mentioning doors, so you're well aware of the in-use fleet reg, but this is focusing on engine manufacturers and the engines that they certified in their standards.
And CARB has a separate program for portable equipment, as do many of the air districts, that would apply to things like generators, in-use generators.
Thank you. The next question is from an anonymous attendee, but this comment is feedback regarding OBD requirements. Mr. Laris mentioned that the importance of the topic, and that is to protect public health. Diesel particulates is a very toxic component. I think it will be important for the real system to also track PM.
Yeah, I'll take that one. I guess first off, thanks for the feedback. We do agree that diesel PM emissions are important. Under the current on-road tracking and reporting program for this real data that's referenced, we're only looking at CO2 and NOx emissions, but we can take this feedback into consideration as we develop a proposal for tracking on off-road engines.
Thanks, Mike. I'm sorry. The next comment is from Nilesh Chudari. Watch out, or heads up, while we are looking to enforce OBD requirements, we need to acknowledge the new IU PR limits for off-road applications, considering the duty cycles as well as a standard applicable need to capable of meeting broadcasting DTC over the dashboard. As of now, in on-highway, we have ISO 27145 applicable standards, which doesn't have capability to broadcast the NOx control measure, like level, quality, or interruption of dosing diagnostics. Here we need to consider these things to be enforced.
Yeah, that question was a mouthful, and it gets into some of the details of OBD. We do understand that if we want to standardize the communication of OBD information, that we need to ensure that the communication standards that we reference in the regulation actually support that information that's required. So, and also if the OBD data through this proposal would be displayed on the dashboard as well as through a scan tool, the standards would have to include the requirements for dashboard displays as well. You know, if that's the way the proposal would churn out, we would definitely work with the standardization organizations like ISO that's referenced here and SAE as well. And we do that to augment the standards where it's needed to be, where it's needed, where the standards need to be changed to be in line with what we would require under the regulation. We do that type of work today for on-road. When we develop our on-road OBD requirements, we work with ISO and SAE to make sure that their standards documents are in line with what we're requiring in the regulation. And we do the same in this instance as well.
Thanks, Mike. I think next we're going to go back to a few raised hands questions. In the meantime, can I ask panelists to click on that they answered these questions in the questions bin to clean up some of our question box. But our next question or comment will come from Jerry Fernandez. Jerry, you're allowed to talk and unmute him.
Can you hear me?
Yes, Jerry.
Hey, I'm stakeholder on portable equipment up there at CARB, and I'm also on the heavy duty inspection and maintenance for the that program. I'm a little confused. It seems like we're stacking regulations, or we're attempting to stack regulations that are doing somewhat of an end around on the previous regulations we just got done doing. So my concern is a lot of my equipment is 2-engine equipment that is in diesel off-road. One of them is a portable equipment that we were told would not be required to have a tier 5. We've been replacing engines, tier 4 engines on those equipment. And now it sounds like we may be forced within the amount of time, a short amount of time, to replace those engines we just replaced. In portable equipment, there was a 17-year from date of manufacture that we were allowed for these engines, and that was the cutoff date in it. I'm just wondering, is CARB talking to the other divisions? I mean, are we talking to truck and bus? Are we talking to portable equipment? It just seems like everything's falling in. Are we talking to advanced clean trucks? Or are we jumping?
Thanks for the comment. Yeah, we do all talk to each other. Thank you. Yeah, and I think what you first, there may be sort of a misunderstanding. So the tier 5 measure that we're discussing here today, and again, it's kicking off a new rulemaking, would be a requirement on manufacturers. So this would be telling manufacturers, if you want to sell engines inside equipment legally in California, these are the new standards you need to meet in order to legally sell them. What we're talking about today wouldn't impose any kind of requirements on people that already have in-use equipment. All it would be is saying that when you buy a new piece of equipment, it would have an engine that's cleaner, just like historically the tier 1, 2, 3, 4 standards. This is just tightening up the standards as has been done in the past. And then you're right, there are other programs that affect off-road equipment and that are in-use requirements. And that's why people are asking here questions about, well, what does this mean for the PERT program? And we're not proposing any changes to the PERT program here. That's handled by completely different folks, and we're not intending to imply that we're changing anything there. And I want to address a question from Kim Burns, who wrote, I have to leave in an hour. Will emergency tier 0 engines need to be replaced in the future? Again, this proposal that we're talking about today is just a new engine standard. So we're not talking about in-use requirements at all. So there's other programs you need to be aware of, the portable equipment program and CARB's in-use off-road diesel rule, that do have requirements for accelerating turnover. And I'd refer you to our website. And if you need any information, you can email us and we'll hook you up with the right people and the right places on our website to get details. But that is not the purpose of this discussion today. We're not changing anything for that. Okay, Christian.
Sure. The next question will be from John Summers. You can unmute yourself.
Yeah, hey, good afternoon, everybody. John Summers from AEM, the Association of Equipment Manufacturers. So first off, I just want to say I thank CARB and everybody for putting this on. Appreciate that we can be engaged. Similar to what Steve from EMA mentioned, we're looking to really engage in this. AEM represents all off-road equipment manufacturers as well as component suppliers such as engine manufacturers. And we have a task force that we've named the Engine Emission Strategy Task Force that's basically monitoring, any upcoming regulations, having conversations about it, and looking for areas where we can provide input or feedback. So I think it was Jeff's presentation. I think that's who went second. There's a lot of specific called out feedback requests in there, which is great. And I think our group will, look through those at our next meeting, and I anticipate we could provide some feedback to those things. So I appreciate, kind of calling out those questions and to the CARB team for saying, here's where we need more information on. So I think I have two questions, and one might kind of turn into just a comment here because I think it was kind of addressed, but there was a few questions in the chat about this too, about the preemptive equipment. And CARB had mentioned a couple times about working with EPA or communicating with EPA. I was just kind of wondering if somebody could just maybe explain that process a little more. I don't know if I know how that would go. And then the second question, I may have missed this earlier, and I can't remember who just said it a little while ago, but there was some dates thrown out about 2024. And then something about 2028. I was just wondering what's that 2024 date? And I guess the real question is when will CARB be able to provide a draft proposal for feedback? Thanks.
Thanks. So I can start, and then, if Jeff wants to add anything. So I think your first question was, what's the process for working with EPA, if I got that correctly or interpreted correctly. So we have been hosting regular meetings with EPA where we've discussed some possible concepts of Tier 5, just the way we shared with you. And so we have regular meetings with them and get their feedback. And so we will continue to do that. And then with respect to board dates that you asked about and regulatory language. So the first piece regarding board dates. So this is a long multi-year process where we come up with concepts and then we go through the SRIA and a proposal, and then finally we'll do reg language, and that's when we'll have part of our proposal as well as the regulatory language. But all that comes in the 2023 timeframe, and then we would continue to host workshops like this where you'd see that language as the years go by. And then finally, that board date that I mentioned, we anticipate going to the board in 2024 or mid 2025 with a proposal. And then if the board adopts this proposal, well, then we're thinking about implementation, that then the manufacturers would have to implement our proposal, which then would be a reg in 2028, 29 time period. And then, I do want to say that after the board approves it, then it has to go through the OAL, that's the Office of Administrative Law, to be approved finally. So those are the timetables. I hope that clarifies it for you. And also I wanted to say thanks for saying that you and your members would go through the presentation and try to provide data and feedback to us. That'll be really helpful.
Okay, the next question is from Jay of LC. Could you please explain more about FELs?
Sure.
Jeff?
Yeah, no, sure. I can jump in on that one. I mentioned FELs in the presentation. It's an acronym. It stands for Family Emission Limit. And it's used in, it's a compliance option for engine manufacturers for the new off-road engine regulations. And what it does, instead of say the standard for PM is 0.02 grams per kilowatt hour, instead of saying every engine has to be certified to that level, we allow manufacturers, if they want to invest money in coming up with an engine that beats that technology, say it's 0.05 or 0.005 grams per kilowatt hour. What they can do is they can average that lower emission level with the previous tier emission level. So under tier 4, the previous tier was either tier 4 interim or tier 3. And they would average that on a manufacturer basis, a product line basis, or based on their averaging sets. So that on average, the emissions will still be at or below 0.02 grams per kilowatt hour for PM. So it's a compliance method. It allows manufacturers to continue producing the current tier or the previous tier engine while they invest resources to come up with a technology that's even better than that's required for some of their product line. And that benefits everyone. It benefits us as regulators, because next time we look to adopt standards, we see that, okay, well, manufacturers are certifying engines, at these lower levels. So that helps us establish feasibility. Now, some of the concerns I raised in the presentation were that the program is administered at the federal level. So it's not averaged within California borders. And that means that individual states, such as California, could be getting more than its fair share of FEL engines that are less stringent than the current standard. So it wouldn't necessarily balance out within state borders. And even if it does, you could have areas like San Joaquin or South Coast, that are getting more than their fair share of these higher emitting engines. So that was the basis of me bringing it up in the presentation. We're looking for ways to ensure that we get an equitable share in the future. We had a research program look at that in 2018, and they concluded that the record keeping and the reporting requirements really weren't good enough for anybody to know, what percentage of the federal numbers they were getting. So I hope that answers your question.
Thanks, Jeff. The next question is from William Martin. Why is the proposed NOx standards for greater than 750 horsepower category so much higher than the mid-power categories? In other words, why are the lower standards not feasible?
And that's a really good question. And we don't know that they aren't feasible. We're looking at certification levels. We're looking at advancements in technology. But unlike the demonstration at Southwest Research, we haven't demonstrated anything above 750 horsepower, to meet much lower standards. We do have other programs within CARB. I think I want to say locomotives. I could be off base here. I think the marine engines, where they are seeing capability of going less than or more than 50% reductions from the current standards. So what I request is that if you have information to this effect to indicate that we can push harder than just a 50% decrease, please, by all means, provide it to us. Thank you.
Thanks. The next question is from Michael Itzel. Regarding the low NOx slide with Southwest Research's John Deere engine, is the engine a Tier 4F certified product, or is it a lesser Tier 3 or compliant Tier 4 non-certified product?
So that's actually a pretty easy one to answer. I can take that one. Yes, in fact, it is a Tier 4 certified product. That 6.8 liters. So our baseline engine is fully compliant to the Tier 4 requirements. But it does kind of bring up the point again that the low load application cycle is below the envelope of what is currently required. So it's kind of pointing out an area where there's some work yet to be done. But it does comply with all the Tier 4 final regs.
Thank you, Chris. Next question comes from an anonymous. Does California have an electrical grid capacity to support CARB's ZEV goals timeline?
Yeah, I can take that one. That's a really good question. The infrastructure improvements will be needed to support the increased demand to our power grid in California to electrify both on-road and off-road, as required by the Executive Order N7920. Discussions in the governor's office have already begun to make this happen, and much of this has been in the news lately regarding both the federal and state efforts to allocate significant infrastructure funding. And as I mentioned earlier, the potential implementation dates of 2028, 2029 for Tier 5 will allow for generous lead time for the infrastructure to be upgraded to support electrification efforts associated with Tier 5.
Thank you, Jenna. The next question is from Tom Umenhofer. In the discussing slide 7, it was noted that the current Tier 4F standards do not reflect BACT, but only engines certified with DPF were identified. Were there any other controls where Tier 4F standards does not reflect BACT?
I can take this one, Christian. I mean, I partially answered this already in an earlier response, but yes, definitely where we're not seeing DPFs on half of the fleet, that indicates that, we haven't adopted truly after treatment based PM standards. And it's not just a question of that averaging that I mentioned earlier. There are engines meeting the Tier 4 final standards, the 0.02 without DPFs. So yeah, that's definitely a big one. I also mentioned our heavy duty omnibus on-road regulation that was approved recently. With the SCR, it's the same technology per se, but they're getting significantly lower emission levels out of the same technology. I want to say 90% lower, but that may be that may not be completely correct, but it's in that vicinity. So we know that the NOx standards that we have in the off-road don't reflect best available control technology when on-road with similar technology diesel engines, can do it at 90% below. And the demonstration at Southwest that Chris presented, they're looking at SCR devices, they're looking at close coupled, other enhancements to it. So it's the same technology, but we're looking for a 90% NOx reduction from it. I also mentioned the European Union, where they've adopted standard PM standards. I believe that they are 50% below than what we have in California and the United States, EPA. So again, our PM standards don't necessarily reflect best available control technology, and we're demonstrating at Southwest that we think we can do 75% lower. So those are the technologies. We're also looking at a new carbon dioxide standard, a first-time carbon dioxide standard, be a tailpipe standard for off-road diesel engines, and that would require the use, or at least what's being investigated, the use of cylinder deactivation technology, a dynamic-based cylinder deactivation technology, which isn't present on current, there's not a standard, but the technology itself isn't present on current off-road diesel engines. So I hope that answers your question.
Thanks. The next question is from Cindy Onajikere. Has there been a technology scan done for NOx emission reductions technology? Are there other NOx reduction technologies aside from the SCR? How feasibility or viable are these for operators to acquire, and how efficient are they?
Okay, I think I'll take this one as well. I'm not aware of any a scan, although it wouldn't surprise me if we've done that regarding NOx emission technologies. There are other technologies. SCR is the dominant and the one that achieves the best conversion efficiency. There's exhaust gas recirculation technologies. I also mentioned the cylinder deactivation technology, which we're looking at to reduce CO2, but it also has an effect on NOx emissions as well.
Thanks, Chip. We have another anonymous question, I think, aimed at Jenna. The Southwest research presentation slide is not available online. Under the link you provided, is it possible for this presentation to be available somewhere else? If not, can it be mailed to all webinar attendees, please?
Yes, when we post a presentation, I think I mentioned this at the beginning, that we had everything posted except Southwest Research on our site. And one of the reasons is we're still working on meeting the Americans with Disability Act requirements to post it. But if you'd like to get a copy of it immediately, please send us an email at our email address. It's tier5@arb.ca.gov, and we can send you a copy of his presentation, or we can, or if you know Chris, you can ask him directly. I'm not sure if we can then email it out to everybody. That may also be an option to all
I don't think
attendees.
we can't email it out to everybody.
Okay,
But send us an email if you need it, please.
perfect.
Okay,
Thanks.
we were supposed to have a 45-minute break here. There's a huge number of questions, which is awesome, and we want to get through as many of these as we can. So what I'm going to suggest is, for the next 15 minutes, let's please have Chris Sharp cover the questions that were aimed at his presentation. So those are questions regarding the Southwest Research demonstration. Those of you that had questions regarding Chris Sharp's presentation, please stay on for the next 15 minutes. We don't mind if you're eating a sandwich while you listen. The rest of you, if folks need a bio break or to grab lunch, please take the next 15 minutes if you don't need to hear Chris's responses. And the rest of the CARB panel will be back at 12:15 to continue answering questions. Okay, Chris Sharp, please, I guess, let's see. Can you take it away, Chris? You can just read the questions that are directed to you, and then please provide your answer.
Okay. Thanks, Kim. I'll see if I can scroll down through here to see those. There were a couple that I mentioned answering. I think I had indicated that I could take those. So I'm just working my way. And I think the next one that I see was something from David Cope, who asked whether the report would discuss adaptability of the study technology to smaller engines with fewer cylinders and associated problems or limitations. And the answer to that is yes. We do recognize that we tried to, in selecting an engine for this demonstration, we tried to hit one that was kind of in the middle of the technology range, if you will, that would have the broadest applicability. But that's always a little bit of a fraught choice when it comes to off-road engines, because they do cover such a wide range of power categories. And I think so, especially when we start talking about smaller engines, that's something where we'll have to, as we discuss the technologies that we select, and even some of the ones that we don't, that's something we'll have to include within the reporting, is how well some of those technologies might or might not adapt to smaller engines with fewer cylinders, or in different situations. The limitation, of course, is that really what we're doing is really only going to apply at most, probably the furthest stretch is down to about 56 kilowatts, because below that would be, the targets would look like being very, very different targets, and what we do is unlikely to carry over in a large portion into that smaller category. There was another question related to elaborating on what advanced aftertreatment systems are. So we showed a couple of examples of the system architectures that we were looking at, and they vary. But advanced is a kind of a broad catch-all term. It can mean a lot of different things. Some of you, looking at some of the diagrams, some of the systems that we were proposing don't look all that much different from a conventional architecture with a DOC, DPF, SCR. But bear in mind that even if they're not, we will be testing the latest generation of catalyst technologies that are available, advanced formulations, that sort of thing, or like smaller changes in technology, whether it's different ways to package these things or manage temperature better. And so, you know, all of those different things can really be considered. There may be some options for things like, you know, adding heated dosing to an existing system might extend the range of it. And especially given some of the challenges that we've talked about, you know, the packaging challenges, some of the cost sensitivities, we owe it as part of a really thorough technology evaluation, we owe it to you know, all the stakeholders to take a good hard look at just how much we can get even out of the existing technology, updating it as much as possible to the latest generations of that equipment. That's got to serve as a start point for how far we can go, and then we can add technology from there, because, you know, we don't just want to throw something out that's like, well, here's all the technology in the world just because it's out there. We want to make sure that we're doing something that's a reasonable choice that doesn't go any further than we need to go either. So that's I guess that's a sort of a broad way to answer a fairly broad question on that one.
And Chris, I think an earlier question asked whether CARB had done a scan of off-road technologies.
Yes.
So you're including evaluating potential technologies as part of the demo project, right? I think that might have been what the, okay.
Yeah, and so there's a couple ways to address that one as well. I know somebody else had addressed that, so I wasn't going to go back to that one. But, you know, part of this is that, you know, in preparing, even going through the technology choices that we are looking at, we screened through a more exhaustive list of possible choices for us. And to some extent, we're actually leveraging work that was previously done for the on-highway work, where we looked at a very broad range of technologies and evaluated a lot more of that hardware. And so we can leverage some of the knowledge that we gained in that program. For instance, we looked at passive NOx absorbers as an alternate NOx control technology at low temperature, but in the on-highway work, those proved to not have sufficient durability to meet the useful life requirements. And there's some cost, some potential cost issues there. So knowing what we got out of that previous evaluation, we took a look with our suppliers to see, has there been an update to that technology? Where has it progressed answering some of the questions from the previous demonstration far enough that we should take another look at them? In the case of that particular technology, the answer was no. And so in a lot of ways, we're looking at what's currently available, but we are leveraging all of our previous development work to try to help us make those informed choices on technology.
Great, thank you. All right, let's take the next one for Chris, which is from Adam Carey. And he notes that the presentation and after treatment concept diagram shows an after treatment system that is 3 feet long. This is the package 2. Is it expected that the same performance could be attained in a much smaller package?
So that's a good question. And I think it would depend on the engine. I mean, certainly with a smaller engine, a smaller package would be expected because the after treatment does scale to the engine. In that particular case, actually, I would actually mention that the development package we're going to look at is a little bit longer than just adding up those numbers because there are some flanges and other things to look at. There are potentially some opportunities to adjust that packaging. The current systems, as I mentioned, actually split some of these things into 2 cans for better packaging, and we could do something similar to that on that one. So there are some, we are looking at different, approaches and technologies to dealing with that kind of a question. We do have our canners who have a lot of experience in both of our package cases working with existing non-road packages. And so we have been working with them to come up with packages that would be feasible for installation onto non-road engines. It's one of the reasons, for instance, that we're not considering close coupled technology because we just don't think that's going to be feasible at all within the non-road space. So we kind of not about feasible at all, but a difficult enough packaging challenge that we really downgraded that technology significantly, specifically with respect to non-road. There are some other technologies that we could look at from a packaging standpoint beyond the ones that we chose to look at, but we also have some limits in terms of how much technology we can look at within the scope and the budget. So we have chosen some technologies that we think give us, the best shot at reaching the targets in a reasonable fashion.
Great, thank you, Chris. I did want to note also that sort of philosophically, CARB is, funding this demonstration work, and Chris and his team are doing a great job. But we definitely recognize that we in Southwest Research aren't able to do all the sort of application engineering that every manufacturer would need to do, and this is really more of a sort of proof of concept rather than, trying to address all packaging issues for every potential design. Okay, thanks, Chris. Let's go to the next one, which is from an anonymous attendee, which asks, is the baseline engine cost considering a solution that has EGR?
Yes. In fact, the base engine that we're using already does, in fact, have EGR, and not just EGR, but cooled EGR. So EGR kind of is part of the base engine package already. And that's expected to still be there. We will continue to leverage it. We're actually looking at cases where we might bypass the cooler and use hot EGR as a way to extend the usability of the technology. But yes, the base engine does have EGR. And so to the extent that you would compare costs, that cost is already included in the baseline.
Thank you. And for those of you who may not know that acronym, that's exhaust gas recirculation.
Yeah,
is
sorry,
EGR.
I should have elaborated on that.
I think the people who wanted to know the answer probably already know that. But okay, anonymous attendee asks, on the after treatment options shown by SWRI, they have a 3 SCR configuration with only 1 DEF injection location in front of the first SCR. Is the expectation that they overdose significantly in order to get any ammonia in the 3rd SCR?
That's actually a really good question, and I'm going to try to answer it at a high level. But the very last slide I showed actually contained what we call a model-based control strategy. And so what happens is that under that strategy, the controller uses a model in the ECM, and we have these kinds of things in production. There's some technology doing the same sort of thing today, in fact, on some applications to a certain extent. It will model the coverage level on the catalyst, and in this case, we will split that. And in the event that we come up from a situation, perhaps we're coming from a high temperature event or a DPF generation where coverage is low, the control system can, in fact, do what you would call overdosing. It will choose to do that automatically as a way where essentially doses well beyond what it needs at the immediate moment so that it can push enough ammonia through the system to have good system coverage quickly in order to achieve maximum conversion. And so that sort of model-based control architecture really allows the system to make much more accurate and informed choices about how much it should and shouldn't dose, versus any kind of a fixed or table-based schedule. And we have kind of a very advanced version of that kind of algorithm that actually looks at where the ammonia is in the catalyst and not just whether it's there or not. So yes, it will be doing that, but those are the choices that are made by the model controller in response to how it's tracking storage in the system over time.
Okay, thanks, Chris. Let's go to the question from anonymous attendee at 1111. Southwest Research noted that the DAC durability protocol will be used. From the chart, Southwest Research will be simulating an 8,000 to 12,000 hour durability cycle in approximately 30 days. This represents an 11 times to 16 times accelerated durability testing. Is this DAC protocol currently approved by CARB or EPA for off-road compression ignition engines, or alternatively for on-highway engines?
Yeah, I can talk a little bit more about the DAC protocol. So this is actually the same methodology that we used for the stage 3 demonstrations, the on-highway demonstration programs. And the process actually is we're actually completing, there's some final validation and correlation testing that's currently reaching its later stages. So the protocol, it's intended right now that the protocol is planned to be approved for everybody to be able to do their durability demonstrations using that protocol looking forward into the future. And so we're using it as a way to demonstrate this technology now. The actual acceleration factor is in fact 10x and is right on 10x. So for instance, from 8,000 to 12,000 hours, that's about 4,000 field hours. We would do that in about 400 hours. So right on about a 10x acceleration factor. And we have previously shown in work, and again, it's being validated right now by both CARB and EPA, that we can accelerate at that level and achieve results that are comparable to running a full duration unaccelerated experiment.
Okay, great. Thanks, Chris. Let's go to the next question for you, which is from John Van Gilder. And he asks, is the OBD system design part of the SWRI program?
So from an explicit standpoint, in terms of the controls, the answer to that question is no. We will not be developing OBD algorithms as part of this. However, this gets into, in terms of the report analysis, and we did something similar with the on-highway program, we will be identifying if there are technologies that may cause, changes or updates in OBD. Of course, it's a little bit different in non-road because there isn't any OBD yet, but we can note where there might be cases where technology could be transferred directly from what's existing being done on highway, and where it requires things to be designed that don't yet exist in on highway. Beyond that, the question of actual non-road OBD algorithm design isn't necessarily part of the scope of our program. So other than addressing potential technology impacts on that level of effort, that's about as far as we'll be going.
Okay, thanks, Chris. Then at 11:41 a.m., David Culp asked, will the SWRI report include evaluation of the limitations of the technologies chosen for package 1 and 2 when applied to smaller engines with fewer cylinders?
Yes, that's a good question. And the answer is yes. And I'll give you a specific example to that, in that when we talk about application of a technology like cylinder deactivation to, say, a 4-cylinder engine or a 3-cylinder engine, where there's fewer options than having a 6-cylinder engine, that's an important distinction to make. And in that particular case, it's one of the reasons that we're also taking a look at something like dynamic skip fire, which would widen the range of applicability of a technology like that. But yeah, we do intend in any one of these cases where we're looking at technology, we do need to discuss whether, any case where is this technology problematic for engines that are either significantly smaller or significantly larger than the engine that we're testing.
Okay, thank you, Chris. So in scanning through the rest of the questions, I don't see any more directed specifically to you. Oh, no, I do. Okay, 12:16 p.m. Southwest Research question. Would lower sulfur levels in diesel fuel help meet the proposed Tier 5 standards? That is less than 5 ppm sulfur versus today's 15 ppm sulfur.
That's a good question. It certainly wouldn't hurt. A lot of that's going to depend on the technology that we use. Sulfur is always an issue for after-treatment systems at almost any level. But as to whether, moving from 15 ppm to 5 would be a significant improvement, to some extent, it's going to depend on the technologies that we end up using. But I guess the quick way to answer that is to say it certainly wouldn't hurt to have less in there, assuming that, 5 would turn into an average of 2 in reality versus the average of 7 or so that we have right now. But I don't know that it would be kind of a major contributor to enabling things that we can't do right now.
Okay, great. Let's do 2 more Southwest Research questions and then we can hop to the other questions. Anonymous attendee at 12:15 asks on the DAC question. So the answer is the DAC is not currently being used by any manufacturer to certify an engine. Is the DAC a proprietary program to Southwest Research, and is Southwest Research going to provide this free to the public?
So that's correct. And right now it's not being used for certification. The plan is we're working on that validation program as a cooperative effort with EPA and EMA and CARB and others to reach that point. We're very nearly there. Originally, DAC was a proprietary program, but as it's translated in, for regulatory use, we don't have any particular ownership over that moving forward. And so the idea is that protocol would be provided for anybody to use. If people want to put together their own facilities to run the same thing, that's perfectly fine going forward. So that would be the plan.
Thank you, Chris. Okay, last question for you, at least in this moment, is did or will Southwest Research investigate the tolerance stack up of different components such as engine, DEF system, catalyst, and sensors to provide a range of, I guess they mean of total tolerance?
At present, we don't have a full-scale study to look at that tolerance stack up built into the program scope. We are kind of doing something like that right now using additional funding that's coming from folks on the on-highway side, coming from folks like EMA or EPA or CRC or other folks that are stakeholders within this. So right now there's only a limited capacity for us to do that. I would expect that we can leverage some of that same knowledge that we gain from the effort digging into this. And some of those will apply to the off-highway as well.
Okay, thank you, Chris. Okay, so Christian Bartolome, are you back and able to take over reading questions again?
I'm back. Having a little bit trouble. I had to re-log in to try and be able to share my screen again. I actually can't see the older questions currently.
Okay, I can keep going here. Okay, so Chris, if you need a break, we're going to cover questions that were directed to you, at least for the next. I think the agenda starts again at 12:30, and so we'll just do 9 more minutes of questions here. Jenna, is that correct?
Yes, that's correct. So we'll continue. We'll take questions and then start up again with the presentations at 12:30. Okay, awesome. Okay, let's go to Joe Campbell at 10:32. I don't think we've addressed this one yet. He asks, why would you work on implementing an additional tier level for non-road instead of developing an electric alternative? Jenna, yep,
I think
I can take that one. Yep. So we need progress both in the near term and the long term. So the purpose of the Tier 5 rulemaking is to ensure that engines are more engines that are more difficult or challenging to electrify are manufactured to the cleanest standard possible. So that's why we're doing both.
Okay, thank you. And then Jerry Fernandez at 10:50 asked, are you working with PERP for the second engine vehicles? As a PERP stakeholder, we were told that there would not be a Tier 5 requirement. And again, this is referring to requirements within the portable equipment program, and we are not proposing any changes to those here. So that's a question for that rulemaking group, and just our adopting a Tier 5 standard wouldn't automatically make a change to the PERP in-use requirements. Okay. Okay, Troy Stabe, and I apologize if I said that wrong, says, the reason we should not do it is because it cost me $189,000 to change an engine. I can't stay compliant and will have to shut down my business if I have to meet these new standards. I should first say that we totally get that the requirements that our board adopts impose real costs on real people, and we're required to do an assessment of those costs and consider cost effectiveness as we consider potential requirements. I do want to note for Mr. Stabe that the requirements we're talking about here are all solely on new engine manufacturers. So they would be something we'd say, oh, you have to meet these engine standards in order to sell legally in California. As someone that owns an existing piece of of equipment, he's talking about changing an engine. This program would not require you to change an engine. It wouldn't force you to purchase anything you're not already purchasing. It would just try to ensure that when you do buy a piece of equipment, it has the cleanest engine possible. So thank you for the question. Okay. Let's see, let's go to 1054, and Jeff Lowry, I think you were going to answer. Anonymous attendee asked, the stage 5 regulation sets a particle number limit. Are you considering a particle number limit for the tier 5 regulation?
Sure, thanks, Kim. We are not. We looked into this, and the control technology that's being used in Europe to meet the particle number standard is the DPF. And what we would likely be proposing in tier 5 would be a DPF level, even more stringent than what the Europeans had proposed in their Euro stage 5 rule. So no, we're not looking at adopting a new standard. Any issues associated with particulate number would be taken care of by the incorporation of new PM technology that would be required under our program, under tier 5.
And Jeff, just to clarify, CARB does have a PM standard, but it's in form of mass, not particle number.
Correct. It's mass-based, not number-based.
Okay, so far we're not considering going to a particle number-based standard. But of course, if people have data on anything, feel free to submit it and talk to us if you think we're going in the wrong direction. Okay, let's take anonymous attendees question from 1054, which asks, with regards to the comment regarding off-highway standards being less stringent than on-highway by 50 to 70%, did you take into account that there's a unit difference? And this, the SI and English unit difference is something that's the bane of all of our existences. And yes, we did indeed take into account that those units are different. But thank you for pointing that out. Okay. Let's see, Jeff, maybe can you take this next one from 1058 from anonymous attendee that's asking about how is CARB thinking about the interplay between useful life, mandatory engine requirement, and future ZEV rules? Will consideration of stranded assets be done holistically across all of these efforts, or simply rule by rule?
Yeah, let me give it a shot. The tier 5 engine rule, it's complementary to the manufacturer targeted rule that we mentioned that would also be potentially proposed for adoption in 2005. That would require everything that can go zero emissions to go zero emissions phased in by 2035. So what the off-road rule, the tier 5 rule is it ensures that the cleanest technology for internal combustion engines would be available should manufacturers still need to build internal combustion engines during that time frame. Now, with respect to the useful life requirement, yeah, I'm not sure that we've given much consideration to how that would overlap with future zero emission rules, but it's certainly something that we'll take to heart, take under advisement, and consider.
Okay, thanks. All right, let's go to Rob. I don't know if I'm going to say this right. Janek's question from 10:30 a.m. And he asked, the on-road market is pushing back on the heavy-duty omnibus result, saying that the demonstrated margin is not enough for system variability and full useful life. Some feedback has suggested that a 50% margin is a more appropriate target. This should be used as the target for system feasibility. So we have received this comment from the Truck and Engine Manufacturers Association asking us to have a different target for the Southwest Research Demonstration Project that Chris Sharp described. And I think the way generally that the folks at CARB are thinking about it is we totally understand that there's a need for a compliance margin and that lots of different factors can cause increases in emissions. And I think those are all important factors that we need to keep in mind as we take the results from the Southwest Research Demonstration Project and think about what it would mean for what would be a feasible standard. However, at least from what we've heard so far, we didn't hear anything compelling saying that we should change the goals of the demonstration program. But if anyone would like to talk to us separately on that, we're happy to continue talking about that. Okay. Okay. Well, are there any other CARB folks who are prepared to answer a question now? Oh, wait, maybe we can go to Mike Regenfuss. Mike Regenfuss, are you on?
Yes, I'm here.
Okay, great. Could you please take the question from 11:06 a.m. from Deepak Guruswamy, who says, does major component monitoring on slide 20 require emission threshold monitors and in-range diagnostics as required in on-road heavy-duty OBD? And what about IUMPR requirements in defining an off-road drive cycle?
Yeah, we haven't settled on any of those details yet. Certainly we're kind of using our reference point of on-road OBD as kind of the spectrum of what an OBD system might entail. And we're looking at, you know, the features of what we have in on-road OBD, and still in a sort of a place of deciding as to what we're going to include for the off-road market. And then I think as we would take some of those on-road features and apply them to off-road, then I think we would have to sort of adjust the requirements to the kind of the off-road specific scenarios, because it can't be sort of a direct transfer of technology without some adjustments. That's for sure, and that's clear to us.
Okay, great.
Thank you, Mike.
Well, all right, Christian, can I hand it back to you? I think we're at the time when we're supposed to start presentation. So I want to thank everybody that gave up their lunch or sat at their computer to listen to the answers here. Really appreciate all the questions and all the feedback we're getting.
Yeah, thank you. I want to move on to the next presentation from Yi Tan from our Mobile Source Control Division. Yi, if you're ready, you can take the floor.
Thank you, Christian. So this presentation will analyze real-world engine duty cycles of construction equipment and assess the need for a low-load cycle. Next slide, please. The first objective of this work is to understand the real-world engine duty cycles of off-road construction equipment. We compare real-world engine duty cycles with the non-road transient cycle, NRTC, and compare real-world engine duty cycles with the low-load application cycle developed in our research contract 18RD006, off-road diesel no-emission demo for nitrogen oxides, particulate matter, and toxics. You can find the link at the bottom of this slide. The second objective of this work is to assess the need for supplemental certification cycle development, similar to the low-load cycle for on-road heavy-duty vehicles. Next slide, please. The real-world activity data were collected by our research contract 17RD013, activity data of off-road engines in construction. And again, you can find the project through the link at the bottom of this slide. In this contract, you see Riverside put engine control unit data loggers on 35 pieces of construction equipment, as shown in the pictures on the right side. Because there are no OBD requirements for off-road engines, it was a big challenge to collect desired data. For example, only 27 engines reported both actual and friction torque values. Engines in this study were relatively new. All of them were 2008 to 2018 model year engines, certified to the Tier 3 and Tier 4 standards. The data covered major construction equipment types, such as loaders, graders, and backhoes. Multiple engines were sampled for each type. The rated power of these engines was in the 72 to 416 kilowatt range, and most engines were above 130 kilowatts. The real-world activity data were recorded at 1 Hertz for at least 4 weeks for each engine. Next slide. The right side figure shows an example of the 1 Hertz data we got from the research contract. For this specific engine, we were able to obtain engine speed and torque values. However, we did not have the reference torque value for this engine from the ECU data. In fact, all the engines in this work did not report reference torque values through the diagnostic port. Therefore, we have to use the normalized engine load to characterize real-world activities. To do this, first, we assumed a reference torque value to calculate the engine output power. Then we normalized all the output power values to the maximum value. The assumed reference torque value was canceled out during the calculation, and we got the normalized engine load. Next slide, please. Today, this is the largest 1 Hz activity dataset for construction equipment. We categorize the 1 Hz data into 11 engine load bins shown here on the left side. Most of the bins are 10% wide. In addition, to better understand low load operations, we divided the lowest load into 2 bins, 0 to 5% and 5 to 10%. The box whisker plot on the left side shows the binning result. The y-axis shows the percent of the time of engine activities. Each box shows the distribution of activities of all 27 engines at a given bin. The horizontal line in the middle of the box shows the medium engine. The box and lines shows the spread of the data. We can see that low load operations are significant for most engines. In fact, for this data set, 21 out of 27 engines had more than 50% of activity in low load bins. That is less than 20% of the normalized engine load. Next slide, please. Current off-road engines are certified over the NRTC non-road transit cycle. When we compare the activity distribution of real-world data with the NRTC, our result indicated that most engines had significantly more low-load operations. On the left side is a cumulative distribution plot. It shows that there is a significant gap between the load distribution of real-world data and the load distribution of the NRTC. The red box whiskers represent the real-world data. As a fleet average, around 63% of activity was below 20% engine load in the real world. The blue line represents the activity distribution of the NRTC. The blue line is well below the real world data when the engine load is below 50%. Therefore, we believe that the NRTC does not sufficiently represent the low load conditions that occur in real world duty cycles. As another example, we compare the average loads of the NRTC and the real world data. The average load of NRTC is about 37%. And the average load of the real world data is 19%, which is significantly lower. Next slide, please. In our research contract 18RD006, Southwest Research Institute developed a low-load application cycle. We call it as LLAC. As discussed by Mr. Chris Sharp in his presentation, this cycle is based on real-world activity data from John Deere. In this cycle, it has extended idling and some PTO operations. And it also has events when the engine works at a very high load. This cycle represents real-world operations of construction equipment and agricultural tractors. Please check the link in the slide for more details about this cycle. And you can also refer back to Chris's presentation for more information. In this work, we will also compare our real-world data with the LLAC. Next slide, please. Here we show our results our comparison of real-world data and the LLAC. The left side is a cumulative distribution plot comparing the LLAC with the real-world data. Again, the red box whiskers represent the real-world data, and the blue line represents the LLAC. The average load of LLAC is about 15% of the maximum power. In comparison, the average load of NRTC is 37%, and the average load of the real-world data is 19%. As indicated by the plot, the gap between the LLAC and the real-world data is relatively small. This suggests that the LLAC better captures the real-world low-load operations than the NRTC. It is important to note that the LLAC is not supposed to match all types of operations, but it is a very good starting point for us to better understand real-world operations. Next slide, please. Low-load operations could have significant emission impacts because the SCR becomes less effective when the exhaust temperature is low. Southwest Research Institute tested a 6.8 John Deere engine over different cycles in our research contract. The results showed that NOx emissions over the LLAC could be several times higher than the standard. In comparison, emissions over regulatory cycles such as the NRTC and RMC were well below the standard. Therefore, compliance over the NRTC might not adequately control low-load emissions in the real world. Therefore, we believe that developing a certification low-load cycle, LLC, for off-road engines could be beneficial. Next slide, please. In conclusion, real-world data indicate that low-load operations represent a significant portion of activity for construction equipment. The current NRTC does not sufficiently represent the low-load conditions that occur in real-world duty cycles. In comparison, the LLAC developed in research contract 18 RD006 more closely represent real-world low-load operations. Since the low NOx demonstration engine had significantly higher emissions over the LLAC than over current certification cycles, we believe that a certification LLC low-load cycle is critical for controlling real-world emissions. In the future, we will gather and analyze more activity data from construction and agricultural equipment. Again, as Mr. Jeff Lowry mentioned in his presentation, staff requests feedback on whether SouthWRI's LLAC can serve as an off-road certification cycle to ensure emissions are controlled during low-load off-road operations. And thank you.
Thank you, Dr. Yitan, for your presentation. Next, we're going to go to presentation by Ivan Castillo from the Emission Certification and Compliance Division. One second while I load his presentation. Okay, Ivan, if you're ready, you can take the floor.
All right, thank you, Christian. Hello, my name is Ivan Castillo. I work in the heavy duty end-use compliance section. I'm primarily involved with on-road heavy duty end-use compliance testing, as well as supporting the off-road end-use compliance pilot program. And today I'll be talking of a few concerns and items regarding end-use compliance that have to be considered for the upcoming Tier 5 regulation. So some of these items have been covered by other people earlier today, but this is just more from a perspective of the in-use compliance testing side. Next slide. So on this slide, we have a summary of the current regulations. So these are existing regulations that give CARB the authority to conduct in-use compliance testing of off-road engines and conduct a recall accordingly if emissions are over the standard. Next slide. Okay, so on this slide, we have an overview of CARB's off-road in-use compliance pilot program. So over the last couple of years, staff has been working to develop an off-road in-use compliance based on current regulations. And this is to ensure that vehicles and equipment meet CARB's certification requirement and maintain emission compliance throughout the useful life. In addition to NTE testing, we do additional testing such as AECD screening and SCR inducement testing. And valuable findings from this initial work are going to be described in the following slides. Next slide. Yeah, so on this slide, we have the current status. We've been working with 5 different off-road engine manufacturers. We have data logged over 25 pieces of equipment ranging from wheel loaders, excavators, graders, dozers, and there's a few others that we've data logged. And the engine displacement ranges from 3.5 to 15 liter. We have also tested 3 pieces of equipment using PEMS, portable emission measurement systems. And we've completed inducement testing on 2 pieces of equipment, and that included low def, poor quality, as well as tampering. And we continue to data log, conduct PEMS testing and inducement testing, and conduct AECD evaluations. And all of this will support the official off-road in-use compliance pilot program, as well as inform the upcoming Tier 5 regulation update. Next slide. So on this slide, we have some of the findings. So I think industry is well aware of the challenges that are faced when conducting testing of off-road equipment. One of the major hurdles is the lack of OBD standardization. This includes the port, the physical connector, as well as the communication. This is varies from manufacturer to manufacturer, and in many cases, it's intrusive. So it requires either the use of proprietary tools or an intrusive breakout box. And when dealing with fleets and users, we want to minimize the downtime as well as the inconvenience to them. So that's definitely a challenge when you have to tear apart their ECU or just do some sort of intrusive data logging. So that's definitely one challenge that we have to address. Another item is observing different inducement behavior within the same engine family. We do acknowledge that there is difference depending on how the vehicle is operated, and of course on the DEF quality or the DEF level that it was initially started with. But that's definitely something that's still ongoing. A couple other items is that some equipment does not operate within the NTE window during normal operation. So that has to be addressed in future regulations, as well as some equipment, just due to the nature of work or the calibration, it never reaches the 250 degrees Celsius, which creates a automatic pass based on current regulations. And lastly, we have the lack of appropriate emission label placement. So the current regulations are pretty specific in regards to engine emission label placement. It does allow for a secondary label if the primary label is not visible or is not sufficient. So that's something that industry has to employ, given that just because the engine has a label, if it's not visible or not accessible, it's not meeting the requirements in the current regulation. Next slide. So on this slide, we have a few other findings. They're somewhat of a follow-up to the previous slide. So based on our current data, the NTE protocol is not adequate for off-road engines. The NTE protocol does not capture all types of operation, and particularly idle and low load. And also because of the after treatment temperature exclusion. And then the off-road equipment, the operation ranges widely. So some equipment may not operate for 30 seconds continuously and therefore may not reach a valid NTE events. And yeah, this makes it difficult to conduct a appropriate assessment of the engine for compliance. Next slide. So this just goes into a bit more detail about OBD and CAN communication. So in order to facilitate PEMS and in-use compliant testing, possible concepts include standardization of parameters, standardization of diagnostic ports, predefined parameters and information required to support PEMS testing that should be publicly broadcasted and not require any intrusive breakout boxes, as well as functional and threshold monitors. Next slide. So on this slide, we have a bit more information on SCR inducement. So as part of the off-road in-use compliance pilot program, CARB tested two pieces of equipment with the same engine family and the same engine power rating, and resulted in completely different inducement behavior. Low def quality inducement study resulted in one equipment inducing as described in the certification documents, and the second one did not induce after extensive operation. And this was, I'll just say, poor def quality. So it's not referring to the level, it's referring to the quality of the def. And both equipment had the same quality of def, and we observed completely different behaviors. So this is something that we continue to investigate, and we would like addressed in future regulations. Next slide. So on this slide, we just bring up the topic of a manufacturer-run in-use compliance testing program. So this is currently not required for off-road. It is required for on-road. So we propose something similar. Of course, the NTE evaluation method is not adequate, so that would have to be different. And for this off-road in-use compliance testing program, could help ensure compliance to the standard. And this could be done through either in-use testing with PEMS or in-use testing using the engine dyno, or possibly telematics could be an option. We are open to suggestions, but it seems that this is something that needs to be done. So possible concepts for the analysis method include the moving average window or binning method. Next slide, thank you. So in conclusion, CARB's pilot off-road in-use compliant program indicates a need for OBD, communication standardization, a more robust protocol than NTE that more adequately captures a variety of operation, SCR inducement standardization. And for next steps, we continue to develop the off-road in-use compliance program, which is critical for controlling real-world emission and assessing what's actually happening in the field. And then lastly, we continue to evaluate NTE versus the moving window average, as well as other methods for in-use compliance determination. Thank you for your time.
Thank you, Ivan. I guess we're gonna go back to our questions and open discussion. I'll go to some with their hands raised. Jeffrey Fernandez. If you're still there, you can unmute and ask your question. I'm sorry, Jerry Fernandez.
I didn't have any other questions. I'm sorry.
Okay, then, well, sorry, one moment, please. We'll go to Steve Berry.
Thank you, Christian. Thanks for the presentations. With respect to the low load cycle, we understand the interest to address light load emissions. When it comes to the cycle itself, it's a very complex issue. Again, the non-road space with all the different power ranges, product ranges, specific applications. It's important to get this right, and we're hopeful that CARB doesn't take the easy route of simply applying the LLAC because of the way it was put together without the kind of thought useful for its purpose, but not with the kind of rigor that would be expected for a certification requirement. So we're willing to work with you on that, and hopefully we'll have something that doesn't end up being 90 minutes long like we have in the highway omnibus requirements. Linked to that, the application of cylinder deactivation as a key light load technology. We have to be very cautious about the NVH implications. I know that Southwest addressed that issue with proper phasing techniques and such, but if you, I'm sure you recall from your discussions with the Class 2B3 vehicle manufacturers in developing the omnibus rule, you have a good understanding of what of the engineering effort it takes to integrate CDA into a single vehicle model and address properly the NVH issues that arise. And again, we're back to the non-road diversity, the number of different applications, the number of different OEMs that build equipment and that will have to manage these very complex installations to avoid NVH concerns. And do they have the technical skill to do that? So something that we have to watch out for very carefully in considering CDA as a viable technology. To the issue of PEMS testing, we also wonder if there aren't alternatives that can be considered. We know that EU and China is looking at NOx sensor, look at the NOx sensor as a tool to observe the overall compliance level of equipment. Also, Euro 7 is delving into that space, and it could be a way to avoid the very complex action of PEMS testing on non-road equipment. So something to think about there, and we're looking into that possibility as well. Could play into OBD as well, as a means to avoid the very prescriptive, very complex requirements of the OBD regs in the highway space for the non-road applications. And to that end, my question, thanks for your patience. On the highway side, the cost benefit of OBD, I think, is a bit of a challenging hurdle to be made even more challenging in the non-road space, again, with all the diversity of product and applications, et cetera. So we're curious to know if ARB has already begun to pencil out some sort of cost benefit analysis, even at this stage, and what you might see as the key differences between the application of OBD in the non-road space compared to what's done today in the highway space, from a duty cycle and an application point of view.
Thanks, Steve. I guess I can take your questions. I appreciate your comments, and I jotted down some of them. I appreciate your idea for alternatives using some of the suggestions on Euro 7 or using NOx sensors. And what would be great is if EMA can come up with some proposals on manufactured in use testing and OBD, that would be much appreciated. We'd really be interested in your ideas. And then the other question was, do we have any cost benefit data for OBD? We do not yet. So that'll be coming in the next couple years or so, in the next year.
Okay, thank you, Jenna. The next question or comment will come from Christopher Chavez. You're allowed to ask now.
Yes, thank you. My name is Chris Chavez. I'm Deputy Policy Director of Coalition for Clean Air. A few comments, and my apologies, I'm going to have to jump off this webinar or this workshop fairly soon. But just for Coalition for Clean Air's part, a few comments. We wanted to support the creation of a Tier 5 engine standard for off-road vehicles, as well as urge for the expedient turnover and retirement of older engines, which are highly polluting and contribute to the region's poor air quality, both in terms of smog-forming pollutants and health-harming pollutants. As CARB's data noted, off-road engines currently or will soon exceed NOx emissions from on-road vehicles. So it just goes to show a lot of work is needed in that space. We would hope that the deployment of Tier 5 engines would include both off-road vehicles as well as equipment such as backup generators and other diesel-powered engines, equipment engines. Again, we need to make sure that we're covering the gamut of engines that are out there, particularly in sensitive communities, which gets to my next point. That CARB should also work to ensure deployment of Tier 5 engines in disadvantaged and AB 617 communities. Finally, just want to emphasize that the deployment and development and deployment of Tier 5 engines should not delay or weaken CARB's commitment into deploying near zero and zero emission solutions, which really are the gold standard in achieving emission reductions and improving both air quality and helping the state meet its greenhouse gas reduction commitments. Those are my comments. So just wanted to thank you for all this information, and take care.
Thank you very much. Your comments are noted.
Okay. Next, we'll take a question from an anonymous attendee. They're asking, the link on the LLAC just circles back to the presentation. Where's the actual data from the 27 pieces of equipment? I think Yi would like to answer that.
Yeah, I just double checked the presentation posted on our website. It goes to the right link. And if you still have questions, please feel free to contact us. And for the data belongs to UC Riverside. And you should contact Dr. Tom Durbin at UC Riverside for the access to the data.
Okay, thank you. Another question for you, Yi, comes from Frank Seymour. Is the off-road LLC ready to use by the manufacturers as part of a DF, or is additional work needed to be done to complete the development of an LLC?
Jenna, do you want to take on that?
Sure, I'll take this one. So actually, it's not ready to be distributed. This is something that we're thinking about. The LLAC is something that Chris Sharp is developing, and we're actually looking for comments from manufacturers to see whether or not we can use the LLAC in place of a low load cycle, right? Because the LLAC, as Chris mentioned, it takes 4 different cycles and it puts them together, and we're doing a study based on that, but it's not going to be an official cycle. So we're looking for feedback on that.
Thank you, Jenna.
Okay.
Another question from anonymous. Isn't the argument for needing an IUC solely dependent on the issues pointed out that support the LLC? Given difficulties and complexities with this testing on off-road applications, why not hold off to determine the benefits of the LLC requirements first?
Jeff, did you want to take the stab at that one?
Yeah, but is that one of the ones that was submitted through the Q&A, Christian?
Yes,
Yeah,
that
it
was
was.
submitted at 12:50.
Thank you. 12:15. Yeah, just let me
Oh,
read it.
12:50.
12:50. All right, hold on.
And then we should probably take them in order going forward, Christian, so we can find them.
Oh, sorry.
But
I started taking questions like from our second section.
I see.
At
Okay.
12:30.
Yeah.
There's
Understood now.
One more time. What was the time date or the timestamp?
12:50.
12:50.
12:50.
Thank you. Yeah, just give me a second. Let me read it over.
Sure.
Okay.
I think I could just take this one. So anonymous attendee 1250. Yeah, thank you for your input, and definitely for all the parts of the program that we're talking about today, we're evaluating whether they're needed. And so if your point here is that you don't think we need a low load cycle, or that you think it needs more study, that's noted. But if you had something more specific to say and you want to talk to us, then that's welcome as well. So the information that we have so far is suggestive of the need for better controls during low load operations, and that's what we're proceeding with so far. But if anyone has data or arguments that contradict that, then please talk to us, and it's helpful if you identify yourself. So I think that's okay, Jeff, unless you had anything else to add there.
No, that's fine. I was just going to add that, the whole purpose of an in-use compliance program is to make sure that the emissions control systems are performing as intended in use. And yeah, the low load cycle, we would want to make sure that engine operation during low load operation, and emissions controls are operating as intended. So that's all I wanted to add. Thank you.
Oh, okay, thanks, Jeff. And then Christian, I like your idea of just continuing for questions that came from these two presentations. So continue on at date stamp or timestamp 1254 about where is the data on the in-use testing.
Yeah, 1254 anonymous. Where is the data on in-use testing? Maybe Ivan would like to respond to that one.
Go ahead.
Okay, sorry, Ivan. So the in-use testing data that we have available right now, it's part of the pilot off-road in-use compliance project. It's in the works. We are hoping that by early next year, we are going to have an SOP to final SOP to support the in-use compliance for off-road programs. And any data that we will be available to share, we will provide to the Tier 5 group and be presented at a later time.
Thank you, Elena.
Can Elena take the next question as well?
Sure. It's from Jesse Sampson. Is it a requirement for off-road vehicles to have emission labels on them? I was told by one dealer that it was not necessary.
So I want to be very specific here. We are talking about off-road engines. These off-road engines are can be found in off-road equipment. So the regulations we currently have in place do request the off-road engines to have an emission control label. That label should be visible and readable, as well as durable for the useful life. As Ivan mentioned earlier, we do have the we believe the current regulations are very, very specific. We are just trying to remind manufacturers that they can make full use of the option of using duplicate labels on the equipment as well, just to help, enforcement group, INEOS compliance group, operators and dealers to quickly find the engine label and the specific to the engine going into their equipment. I hope that answered the question.
Thank you, Elena. The next question is anonymous. How do you propose to force OBD and commonality of outputs for applications that do not employ ECU controls?
Yeah, hey Christian, this is Mike Reaganfuss. I'll take that question. I guess first off, I'm not sure that I completely understand the question, but I think it might be in the context that there might be some engines that are currently certified that are completely mechanically controlled. If that's the sort of the background behind this question, then at this point, with my understanding of the tier 5 emission levels that we're looking at, that I would expect electronic controls to be necessary to meet the tier 5 requirements. And if that's a sound assumption on my part, then if there are those electronic controls, then I think there's the basis to build an OBD system. I guess if that's sort of missing the point of the question, then perhaps that individual could reach out to us and we could talk about it more.
Thank you, Mike. The next anonymous question at 102, they said it's a comment only, but they agree it would be very helpful if staff could potentially find a way to share the actual modal or second by second data from the 27 pieces of equipment tested, some type of blind data set, maybe by application or by power rating with XX to YY range. And I think you would.
I can jump in here. I think right now that data is, it sort of belongs to a different group, but first of all, before we rely on any data in a rulemaking, we're required to include that in the official rulemaking record, which is then viewable by the public. And what we can do between now and when we're at the point of making an official proposal is reach out to, I think it's Tom Durbin who has that data, and see if we can make it available or make it available in some anonymized fashion. So we're definitely sensitive to wanting to share the information that we're looking at so others can be looking at it too. So let us take that back and see what we can do.
Thank you. Okay, I'm gonna go back to a few questions from earlier in the day from Randall Venerable at 10:24 in the morning. Has CARB addressed the current technical fault issues with tier 4 final technology with DEF failures? In particular, the issues of having to shut the engine off and replenish DEF fluid. This is a concern when running a generator during an emergency 24/7 power outage operation. And I think Kim would like to respond to that.
Christian, I don't know which one you're referring to. Sorry.
This is Randall at 10:24.
Okay, let me go back there. Oh, okay. Yeah, thanks for the question. No, I personally was not aware of that. And so we will circle around with the relevant folks. But if you can, Randall, if you can talk to us one-on-one, so to make sure that we're looking at the issue that you're actually thinking of, that would be very helpful. So if you could give us your contact information, we will work with you to make sure we look into that.
Thanks, Kim. The next question is from George Lynn at 11:11 a.m. I would like to support the statement made by the earlier speaker. I'd like to request CARB to determine and quantify the emissions reductions from today. If all equipment went to tier 4, then state how tier 5 would add benefits to that.
Okay, I can answer this question. Actually, I found some figures. If I can share screen.
Sure.
Oh, I cannot share screen actually. Oh, let me see. So here is actually, can you see my screen?
Yes, yes, we
So
can.
here is actually a slide in our mobile source strategy presentation. This shows the emission benefits of replacing all tier 0 to tier 2 equipment by 2033. You can see it's about 7.5 ton per day NOx reduction in 2031. But the majority of the emission is still by tier 4 final, and we did another scenario that replacing all of them to tier 5. So here you can see that now we have actually much more emission reductions. And in 2031, it's 10.2 ton per day, and by 2050, the emission reduction is much more. So here's the data showing the benefits of tier 5. I hope that answers your question.
Oh, thank you very much, Leon.
Leon, that's probably a lot for folks to digest.
Okay.
So I think probably we should work with you guys to like prepare a follow-up slide or a little summary that we can either present at our next workshop or post on our website somehow. But
sure.
Yeah, thanks.
Sounds good. Yeah, but we have the data and we can show like tier 5 definitely still have lots of benefits on top of tier 4 final.
Awesome, thanks.
Thank you. The next comment is from Jackson Kwiatkowski. Is there a plan to remove the agricultural exemptions of running less than tier 4 engines? We sell equipment to farmers, and sometimes because they don't want to follow those regulations.
Kim, this was for you at 11:14.
Okay, hey Christian, when you start reading them, a lot of us are multitasking. So say the name of the person that you're assigning it to whom it pertains, because otherwise you're going to get this dumb pause like I'm providing
Yeah, I'm
right
sorry
now.
for putting you on the spot by saying yours last and not announcing you. So I'll announce the person who's planning on responding to this ahead of time.
Okay, so which one are you talking about now?
This is at 11:14 from Jackson Kwiatkowski.
Okay, yeah, thanks for the question. Okay, and again, the requirements for the in-use requirements are in other programs. In this case, the in-use off-road diesel rule contains in-use requirements, and that rule does currently have exemptions for agricultural use. Based on this question, I checked with the team that's working on that, including lead staff Nathan Dean, and they are not currently proposing any changes to those exemptions. And so there's different reasons why we might have different requirements for different industries, but so that provision would still remain in place as far as what's been proposed so far.
Thank you, Kim. The next question is for Jenna Ladd from Matthew Jones at 11:14 a.m. Will there be a financial impact study completed to the AG point?
Yeah, I think this dovetails off of what Kim just said. They're not changing any of the exemptions for ag, so that should be a moot point. But for all our regs, yes, we do consider and we do perform a cost benefit analysis.
Thanks, Jenna. This is going to be another question for you. Where will the recorded Zoom meeting be available and how soon?
Yes, we hope to get that done either by the end of the day or tomorrow. It'll be the recording will be available to the public by tomorrow.
Thank you. Next question is for Jeff Laurie from Adam Carey at 11:25. If the follow-up questions arise after this meeting, who is the appropriate contact to send those to?
So I'm
Okay.
here. Sorry about that. I just had to find the mute button, which is buried under a number of screens. Yeah, if we don't have time to address your questions, send them to tier5@arb.ca.gov. And I believe Jenna has a slide at the end of the workshop which has that email address. Or alternatively, you can send any questions to me regarding the Tier 5 regulation. It's jeffrey.lowry@arb.ca.gov.
Once again, I'm just going to put the contacts slide up, maybe if there's any questions that we can't get to in the future.
Let me just do a few while Christian's doing that. So at 11:26, Gordon Gudarzi said, we have on-road Class 8 CNG hybrids demonstrating more than a 2-time fuel economy. I guess that's improvement over 4 years of operation, greater than 80% NOx reduction, off-road diesel electric vehicles like sweepers in New York showing a 2 times improvement in fuel economy and 70% emission reduction. Your ruling should include support for vehicle powertrain system efficiency and emission reductions, in addition to holding engines responsible to a certain emission reduction. Thank you for that comment. That's not currently our plan. There's a lot to do, and we're trying to carve this up into digestible pieces, but definitely is something we could address in a future rulemaking. But thank you for your suggestion.
Thank you, Kim. The next question I have is for Mike Reagan first. Can you please comes from Anonymous at 11:30. Can you please elaborate more on the level or depth of OBD intended for off-road? Is this essentially going to be a transplant of current on-road level for OBD to off-road? Or is this going to be catered more to a high level of variation of application use cases and OEM engine markets?
Yeah, we don't expect to transplant the current heavy duty on-road OBD regulation verbatim to off-road. You know, we're looking at what to require and to what not require. Where we would propose to transfer sort of an aspect or feature of the on-road requirements to off-road, we would look at adjustments that have to be made to make it feasible and effective for off-road engines. So I think we're still in the early stages, and you know, if you know this commenter or others sort of have more input, sort of about where those boundaries should be and what it should look like, we're open to that discussion.
Thank you, Mike. The next question is for Jenna Latt from Gordon Abbas Gudarazi at 11:27. Also, the emissions should include a multi-drive cycle, which is more representative of the operation, such as ports, municipalities, etc. I do conclude with Southwest Research Institute results that the actual operations emissions at the port is 10x of the so-called SS emission levels. Thanks for the opportunity to provide this comment, and appreciate your leadership.
Okay, thank you very much. Your comment is noted.
The next comment is for Jeff Laurie, anonymously sent at 11:30. Will there be a consideration for EUL, effective useful life, based on horsepower range? Smaller engine machines usually are not designed for the same durability targets as larger, expensive machines. Thus, there would be an unnecessary cost additions for smaller engine systems.
Okay, thank you, Christian. Definitely. Our considered proposal right now and what's being looked at Southwest Research would be for engines 56 kilowatts and greater, for which the current useful life period is 8,000 hours. I think I totally agree, you know, regarding the smaller engines and the necessity of extending their useful life. It may not be practical and it may not be appropriate emissions wise. Thank you.
Thank you, Jeff. The next question is for Jenna and sent anonymously at 11:32. Why tier 5 for non-road engines? Why not just the electric that will meet the governor's goal of zero emission by 2035? Because tier 5 is still not a zero emission solution. How would state explain to the California residents until zero emission is launched?
Okay, thanks for your question. Yeah, the purpose of Tier 5 is to ensure that the engines produced that, that are more difficult or more challenging to become zero emission are manufactured to the cleanest standard possible using BACT. So the purpose of Tier 5 is to address near term, to address progress in the near term.
Thank you, Jenna. I think the next question here will be answered by Kim. This comes from Jerry Fernandez at 1136. On-site checks for PERP would also be conducted by the local APCD.
Yes, that's true. Thanks for that, for noting that the portable equipment requirements are enforced by local districts. Thanks. I can take another one. Christian, 1138, Jose Mesa said, are the Tier 5 standards going to be included into the CARB compression ignition engine for forklift regulations? And I think what Mr. Mesa is referring to is there's another rulemaking looking at zero emission forklifts, looking at requiring use of zero emission forklifts. And so that specific in-use zero emission forklift regulation is not specifically referring to the Tier 5 standards. However, the Tier 5 standards would apply to any new compression ignition engines that go into any equipment. So if someone were purchasing a diesel forklift in future years when the Tier 5 emission standards were in effect, then that forklift would become equipped with an engine that's compliant with these Tier 5 standards.
Thanks, Kim. The next question is for Mike Regenfuss from George Lynn at 1135. Would zero emissions, for example, battery electric, non-road engine equipment have OBD requirements?
Yeah, that's a good question, George. We get that one a lot in the space of zero emission vehicles. We don't have anything proposed or formulated right now, but I think it's something that we would definitely look at. I think, gosh, I don't know when it was, within the last few years, there were some ZEV requirements to applied to heavy duty vehicles to talk about sort of access to service information and repairability of those vehicles. So that is an important concern of ours. I think in the light duty space right now, there's a discussion like this happening, and it's kind of focusing on, I guess, getting information to consumers or owners or operators sort of on the state of health of their equipment, so that they personally know what their equipment is doing and what its condition is, or if there's someone looking to buy a zero emission vehicle, that they can sort of look at the state of health of that vehicle and maybe get a sense for, what kind of life it has left in it. So I think we would probably take, similar views as we look at what would be required for OBD type of requirements on zero emission off-road equipment.
Thank you, Mike. I think the next question is for Jenna from Adam Carey at 1137. Throughout this Q&A, there's a lot of areas CARB has stated they're requesting feedback from industry. Can ARB please consolidate all these areas they desire feedback regarding the proposed regulations due to the industry knowledge needed?
I think we can do that for you. It's also on the slides in blueprint at the bottom in bold. So if you want to get started immediately, but I think we have it consolidated as well.
Thank you, Jenna. We have another question directed towards Mike here from Michael Reed at 1145. Thank you for the discussion today regarding OBD off-road. Please consider a gentler phase-in like the heavy-duty OBD 13 CCR 1971 for a period until 13 CCR 1971.1/.5. There are considerations that need to be understood regarding the operator and bystander safety to meet machinery safety regulations and directives. Intrusive monitors would need to be understood well by the equipment controls and hierarchy determined safety, or OBD.
Yeah, I'll take that one. Thanks for the comments, Michael. Yeah, definitely the phase-in for on-road heavy-duty OBD was an important one for the manufacturers, and we recognize that. You know, we typically do have, like this example that Michael stated, we typically do have phase-ins for OBD requirements in the on-road space, and we would certainly look at them for off-road. I can't say exactly, excuse me, right now what those would look like for off-road. I think we'd have to develop the technical proposal first, and then look at the phase-ins that would make sense in the context of the technical proposal. For example, certain OBD features, sort of implementation or phase-in of certain OBD features might be emphasized for early implementation over other features. We heard you heard just a short while ago in the in-use compliance presentation that standardized access to onboard data is important for in-use compliance activities. And that would be an example of something that we might emphasize for early implementation. On the other comment regarding sort of intrusive monitors and sort of how it's important for I guess equipment operators and bystanders to be aware of what's going on with their equipment. I think we'd like, I don't appreciate, I understand sort of I understand the nature of the comment that yes, safety is really important, but I guess I don't understand like the real example there. So we'd welcome more discussion on that topic to better understand the nature of the issue. But it is certainly something we would want to talk about.
Thank you, Mike. The next question is directed at Jeff. We received at 11:47 anonymously. The useful lifespan, based on useful lifespan, equipment that we are cycling out or using for Carl Moyer and farmer program applications are in the 20,000-ish or more hours of operation. We use equipment dependent upon the application of 800 to 2,000 hours annually.
Yeah, thanks, Christian. I'm guessing this is pertaining to our proposal to, or our potential proposal to extend useful life. 20,000 hours, that would suggest that it goes even beyond our proposed 12,000 hour useful life period. Of course, that data, I haven't looked into it, but from what I'm seeing here, doesn't indicate whether or not the engine has been rebuilt or replaced during those 20,000 hours. So, more research would have to be done to figure out if that's something that genuinely supports the 12,000 hour proposal. And the 8,000 to 2,000 hours annually, that's good to know. 8 years, so that would be 16,000 hours if you went by the higher number, the 2,000 hours annually for the 8-year period. So it's good information. Thank you for the comment.
Thanks. We have another question for you here, Jeff. Checking 41 used JD tractors for sale on tractorhouse.com between 2012 and 2015. The average annual hours was only 689. That's for a tractor. A harvester only works during harvesting. You can check for yourself.
Yeah, I think the commenter makes an interesting point. For this particular application, it's only putting on approximately 700 hours a year. So obviously that wouldn't hit 12,000 hours for a long time. It wouldn't even hit 8,000 hours for a long time, which is the current useful life period for those. So it's definitely support information. I appreciate the comment. And it's something, we will consider if and when we do propose longer useful life periods. Thank you.
Thanks, Jeff. The next question is for Van Lu. We received anonymously. at 11:53. Sorry, but going off by Sunbelt off I-5 and Oceanside, I see a lot of equipment just sitting there. My question is, are the emission inventories real?
Thanks for your question. Actually, CARB has quantified because of COVID, like the recent congestion in California ports, there's been increase in the anchorage emissions. And I think CARB is working on, just found a document. I didn't quite look into it yet, but I think it's quantifying the increased emissions just from anchorage emission. I can send that link to you. And also we have the OGV staff in our agency. Feel free to contact them if you want more detailed analysis, but we're definitely looking into that. What CARB is not ignoring this situation. And the emissions will be will be quantified. And I can share the link of the analysis so far.
Okay, thank you, Leon.
Okay.
That was sent anonymously, so we're not sure who to send that to. If you could maybe send an email with your question to tier 5, maybe we can get back to you. Okay, the next question is for Kim, and this is from Robert Hasselbrock, and we received this at 11:55 a.m. Will we expect California to come to a stop when the winds come and the grid is shut down?
Short answer, no. But we definitely understand, like, talking about these goals for electrification sounds great, but there's a lot of real world issues to work out, and there's an acknowledgement that you can't just electrify everything immediately. You have to look at feasibility and cost effectiveness, and that's all part of the reason why CARB is looking at tightening up the diesel standards here, because we recognize that you can't just, it's not easy to just immediately electrify everything. Thank you for the comment.
All right. Well, we have another one for you, Kim, here at 12:06. Oh, it's a comment, I guess. This is not a question, but a comment to be shared with all listeners and CARB staff. I understand that this workshop is to inform the public that the manufacturers are moving forward will be required to sell tier 5 because the cleanest available or the newest technology. What does is that all sets up to prevent other regulations that is not off-road, such as stationary and portable ATCM, to look at tier 5 and recheck the best available control technology analysis?
Thanks for the comment.
The next one is for Jeff here. 1221. You mentioned that 5 to 8.6% CO2 reduction goal would be measured against the JD engine at Southwest Research Institute as a baseline. Could you please provide more detail? How would this be applied to a wide variety of off-road engine applications and speeds?
Christian, who was that aimed at?
That was a Jeff.
Jeff, if you're talking, you're muted. Christian, why don't you hop to another one? It looks like Jeff's having technical difficulties.
Sure. I'm gonna go to a question for Babak, and we received anonymously at 12:27. Sorry if you've already covered this already, but if a tier 5 has controls that might fail during an emergency, is there a consideration to have a bypass allowed so that the equipment can be operated during such an emergency? For example, a public safety incident?
Yeah, good afternoon. This is Babak Zikfat from the certification group. In fact, there are already some provisions in the regulations that allows temporary override for the SCR systems, and it's spelled out in specifically 1039.665 of 40 CFR. But as Jeff have mentioned earlier on slide number 18, they're considering some revisions to add some safeguard so that the provision doesn't get abused. And the reason is when we get the reports back from the engine manufacturer, we realize a lot of time, most of the times, this feature has been used as a convenient as opposed to in a real emergency situation, and we really want to stop that.
Okay, thank you, Buck. We have one raised hand question from Daniel Pinche. If you'd like to state your question or comment, you can unmute yourself now. Daniel, if you're still there, you can try and unmute yourself. Okay, Daniel might not be there. So we'll move on to more Q&A questions here.
Hey, Christian, this is Jeff. I realized I missed one of the questions from 1221. If you'd like me to answer that, I can do that now. It's from
sure.
the anonymous attendee.
Sure, go ahead, Jeff.
Okay, I'll reread it. I'm sorry. You mentioned that the 5 to 8.6% CO2 reduction goal would be measured against the John Deere engine at Southwest Research as a baseline. Could you please provide more detail? How would this be applied to the wide variety of off-road engine applications and speeds? Well, what we're looking at Southwest Research, and Chris went over this already as well, we're looking at one engine, and we're looking to scale the technologies that are being developed for that engine within 56 kilowatts to 560 kilowatts. So, yeah, so for this, there's not a whole lot of more detail, but they're investigating cylinder deactivation, CDA technology, to get to that 5 to 8.6 reduction in CO2 levels. And that would be utilized between 56 kilowatts and 560 kilowatts. So that's the target that we're looking at. Again, none of this is written in stone, but those are the power ranges and the applications that we're looking at. Thank you.
Oh, thank you, Jeff.
And Jeff, we're getting near the end of the time here. Can you please just go through for all the ones that you've claimed? Can you read them out and answer them quickly?
Could I add a quick comment to that last answer, if that's okay?
Of course.
Sure.
I just wanted to mention, because we brought up CDA as one of these, and certainly that's a targeted technology we're looking at. But I want to make sure that it's clear that that's by far not the only thing we're looking at to look at CO2 reductions. We're kind of looking across the board at a number of different possibilities, how we can calibrate the engine and leverage some of the other, what we can do with aftertreatment to allow us to make those reductions too. So CDA is certainly a potential piece of the puzzle, but it's not the only technology that we're looking at.
Thanks for that, Chris. Okay, at 1:06 p.m., Chad Grugel asked if the in-use data used for low load cycle development also includes idle. Shouldn't this be reassessed if an idle requirement is also implemented? These become redundant. If an idle requirement is in place, it would affect the in-use operation profile. Well, first of all, this is a brilliant observation. Thank you, Chad. All of this does affect the amount of heat that's generated in the exhaust that's necessary for the SCR to perform as desired. However, if we look at the on-road, the recent on-road demonstrations, also done at Southwest Research, and Chris, feel free to chime in. There are idle restrictions for the on-road heavy-duty engines, yet we still needed a low-load cycle. There was still a need for a low-load standard and a low-load cycle in order to demonstrate it. We suspect the same will be true for off-road, but we're still acquiring data at this time, and we are open to suggestions. And again, I thank you for your comment.
Okay, Jeff, go on through any of the ones that are assigned to you, please.
Yeah, I'm looking. I don't think I've claimed anything else below that. You want me to go above? Go backwards in time?
Yes.
Okay. There is one at 11:30, also from Anonymous. Will there be consideration, and maybe I've already answered this, forgive me if I have, to extended useful life based on horsepower range? I did answer this, right, Christian? I just didn't.
Yeah, you answered this one, Jeff.
All right, forget that. Let me go back. Okay, one at 11:21. When will CARB provide the underlying data that is quoted in all the presentations? For example, the link to project 17RD013 only provides overview and not underlying data. PIRA website does not provide any baseline data, and also CARB's underlying extrapolation. If CARB will not be providing the data publicly, can the data be requested from CARB, or will it be secret? Excuse me. Yes, I don't have a comment regarding project 17RD013 or response, but regarding PIRA, if you go to the PIRA website, I believe it's pira.org, and go to their FAQ section, one of the questions is, how large is the engine remanufacturing business? And I don't have the information in front of me, but they give a number for North America. So what we did is we extrapolated that number from North America to the United States, to California, to the off-road diesel. And that's where we came up with the numbers in that slide. We have put out a request. I have sent emails in the past to PIRA. I'm asking for, something better if they have it. Just haven't received it yet, but I'm pretty sure that'll be forthcoming. And when it is, we'll post it. And if corrections are needed, we'll make that known. Thank you. Okay, 10:24 a.m. Again, anonymous, my favorite commenter. How does this Tier 5 proposal compare to EU Stage 5 requirements? Well, it's similar in that we have particulate matter mass standards in California and in Europe, and also EPA. We have NOx standards. We have carbon monoxide standards. We have hydrocarbon standards. The differences are that the PM standards that the Europeans have adopted are a little bit more stringent. I say a little bit, I think it's about 50% more stringent than what's been adopted in the United States and California. The Europeans also have an additional standard we discussed earlier for particulates, particulate number. We do have a particulate mass standard, but they have a particulate number standard. We have not adopted that. We likely won't adopt that. As Kim mentioned, though, we are open to the necessity of doing so if it's required. The reason I say it's probably not likely is because the emission control technology for particulate number is the same as for mass. And since we're looking at in Tier 5 PM levels that would be even lower than the European Stage 5 standards, that would require DPFs that are even more efficient. It doesn't make sense, at least to me at this point, to adopt a brand new standard when the control technology addresses the emissions that it would otherwise cover or address. All right, before that, 1020, are GHG reduction targets the same for LLAC, or is that 5 to 9% range geared towards the NRTC and the C1? We are considering it right now for the NRTC. And that would be similar to what was done in Stage 1, which was before a low load cycle was adopted for the on-road Stage 1 GHG. So yeah, we're looking at it for the steady state. That's not to say that it won't be moved or expanded to include the LLAC. But at this time, the consideration and what's being done at Southwest is just for the NRTC. Okay, and the one before that, 1012. When will ARB release specific engine power and equipment categories applicable to Tier 5? For example, will transport refrigeration equipment be included in the enforcement of Tier 5 off-road diesel new engine regulations in the 24 to 2025 period? Okay, I'm not sure I fully understand this, but in terms of power categories, the Tier 4 requirements have specific power ranges, and the standards vary somewhat, between those power ranges. We are looking, at least at this point, when we adopt Tier 5 standards, to have the same power ranges, the same power categories, the same 5 power categories. With respect, they give an example of transport refrigeration equipment. Will that be included in the enforcement of Tier 5 off-road diesel engine, new engine regulations? Again, this goes, I know we brought this up several times to different questioners, but The engine regulations are separate from the in-use regulations, and the transport refrigeration equipment regulation, it's more of an in-use regulation. My understanding is they are going to our board in February of this year to adopt requirements that TR units, which are technically equipment, must have engines that are either zero emission if they're used in trucks, or 0.02 grams per kilowatt hour if they're used in trailers. Although that second part might not happen in February, that may be further off. So anyway, bottom line is, we will adopt standards in the same power range as TR units usually get engines from, namely less than 25 and 25 to 50 horsepower, those categories. We will adopt standards for all engines in those ranges. However, if an in-use program deems it necessary that additional requirements should be applied, as in the case of TRUs, such that some should become zero emission or some should become much lower than required by the Tier 4 standards, then they do that in their separate rule. Yeah, and so that's pretty much it for that question. I think that's it for me anyway.
Okay, great. And I want to thank everybody for, this has been a long day so far and lots of great suggestions and questions. And I see some people have dropped off, but for everyone else, this is going to be recorded. So if you need to leave and come back and look at this later, that's totally fine. I think what we're going to do is keep answering questions here till about 1:55, another 5 minutes. Then we'll finish up the last of the presentation slides. We just had a couple more. And then we'll go back and complete answering the rest of the questions and stating all the comments. All of the comments and questions will be available in the recorded video of this, so none of the information will be lost. Okay, let's see. Jenna, can you take the 11:04 a.m. question regarding please explain supplemental monitor activity data?
Yep, that's actually an on-road OBD requirement, and it's not part of this rulemaking process.
Okay, great. And let me take the 11:06 one. Anonymous attendee states that all CARB presentations and comments overly generalize off-road compression ignition engines. There are 5 sets of standards for various engine sizes and applications. The Southwest Research testing and evaluation on a 6.8 liter engine may not be appropriate for a 2-liter engine. Finally, on CARB's website, an EO noted that one engine family was used for 6 different applications. Off-road compression ignition applications are much more varied in applications, use, work environments, and equipment configurations than similar on highway. What evaluations will CARB be doing for all these varied applications? So thank you for the comment. That's everything you said is true. We'll be looking at anything we adopt in this standard will be something that we believe it's been demonstrated to be technically feasible for any equipment that may use the engine. So we definitely need to take into account that this equipment is used in very varied applications and there's all different sizes, but thank you for pointing that out. Okay, another one, 11:23 a.m. Matthew Jones notes, ag has invested an enormous amount and cycled out a huge amount of equipment. The devaluation of the equipment has forced ag, and that means agriculture, in California to basically give it away to other states and neighboring countries. Ag operations don't purchase new equipment every couple years, as that would be cost prohibitive. Equipment is kept in operation for decades. Most ag equipment is used for periods of time during the year, such as for crop preparation and harvest. Thank you for that note. Again, this rulemaking that we're talking about today wouldn't have any sort of in-use component, wouldn't have any sort of early retirement requirements. Okay, an anonymous attendee at 11:56 a.m. asks, what will the total electric demand for all these electric mandates be? What are the electric requirements for this rule? The other rules mentioned, including trucks and small engines. We described some of the other measures that folks are working on just to put this rule in context. But again, this rule is not it is mostly a standard for compression ignition engines. The one place where we're thinking we might have a zero emission mandate would be for the very smallest engines, the small off-road diesel engines. But we will be fleshing out that potential as we move forward on the rulemaking. And so no, as part of the context of this rulemaking, we haven't looked at quantifying demand. However, other smart folks in state government are looking at that for sure. Okay. Anonymous attendee at noon says, aside from the current infrastructure deficiency, has California considered and accounted for where the additional electricity supply will come from to substitute fossil fuels they wish to replace and consequently electrify? This is a substantial consideration, seeing as diesel and gas energy is currently over 100% of electricity production and would require extensive means to substitute. It seems like you're putting the cart before the horse. Okay, thank you for the comment. I know folks are looking at that, but again, this team is not looking at that in detail, so I don't want to go deeper into that right here. All right, let's do one more. Zhenying Shao at 1209 says, does CARB plan to incorporate zero emission targets into the greenhouse gas limits so as to use greenhouse gas limits to drive manufacturers to adopt zero emission technologies? Up to now, in current staff thinking, we had not been thinking of doing that. We were thinking more of just an emission standard for CO2, but if folks have a suggestion that we do that or have ideas for how we might do that, we encourage you to reach out to us and share your ideas. Okay, Christian. Okay, well, actually now we're at 1:55, so let me stop talking and hand it back. I think Jenna and Jeff, were you going to present a couple more slides?
Yeah, I was going to present on this. So basically, thanks for sitting through our very long day with very few breaks. We appreciate your attention and your strong interest in the topic. Just wanted to go over the next steps. So basically, we'll be forming specialized work groups on different topics that are listed here, the Tier 5 standards themselves, low load cycle development, onboard diagnostics, as well as in-use compliance and testing. So if we suggest that you subscribe at the link listed here to get notification on our upcoming workshops and working groups. So again, this is it's a multi-year process, as we've mentioned, and we're taking it to the board in the 2024-2025 timeframe with implementation in 2028-2029. And again, we request data or alternative concepts or proposals as soon as possible, but really no later than Q4 of 2023. And so next slide. Okay, yep. And so here's the contact information. I think that this slide has been up for a while, but again, we have one email address, that's tier5@arb.ca.gov, and Jeff Lowry is the lead staff in our section, and then I'm the manager of the section. So we'll be, in fact, our whole staff will be looking at questions that come up, so feel free to contact us if you want to meet with us individually or have questions that you want to address through email or that weren't addressed today, or any question that you have, we'll make sure that we answer it. Or you have proposals that you want to send to us. So that email address is the way to get our attention. And then finally, as we've mentioned too, we have a Tier 5 web page, and that is the link to it. So just wanted to let you know.
Thank you, Jenna. So I think we're gonna continue on answering more questions that we have, right?
Yeah, that's the plan. And if
Okay.
anyone from the public who's watching this needs to go, because this was scheduled to end at 2, you can always come back and watch the recording later. We are reading out all the questions that we got so that they'll all be included in the video.
Okay. The next question is anonymous, and I think this is directed at E10 here. or it's a comment. They agree, and it would be very helpful if staff could potentially find a way to share the modal data or second by second data in the 27 pieces of equipment tested. Oh, I think this was already answered. My mistake. I have another comment directed at Elena Flora. And this is from Barbara Records at 108. Do manufacturers know if their engines have been tested?
So the short answer, and I'm answering this question from the INEOS compliance perspective, and hopefully that's where the question is coming from. The short answer is yes, but let me just elaborate a little bit on it. The INEOS compliance program works with engine manufacturers and looks to ensure that the engines and the equipment do meet certification requirements and that they maintain emission compliance throughout useful life. Now, our standard practice is to reach out to manufacturers and have a conversation with them about upcoming testing. Manufacturers do support this testing. They provide us, if we need any hardware necessary to perform INEOS compliance testing, they will do so, as well as engineering support. And let me just take a second here and just, take advantages of this opportunity and say thank you to those overall engine manufacturers that we already started collaborating with. You guys are doing an amazing job, and we are very helpful for the for this successful relationship.
Thank you, Elena. I'm going to go through more questions here. Some of these questions we have already people who want to answer them lined up, but for those on the panelists, if there's any questions that you could take that doesn't have a responder assigned, please sign up for that.
I could take a quick one, which is the 307 question.
Sure,
before
please.
I have to jump off here, I'll try to answer that real quickly. The question was from William Martin, asking, instead of a long LLC, why not a shorter SCR challenge cycle? We actually looked at trying to do that in the on-highway thing as well. And the problem that we run up with here, trying to come up with like a very specific short sort of cycle, is that it turns out to be very difficult to come up with a truly representative challenge that either doesn't, hit with a single short cycle, which probably means you can only really try out one or two sort of low load challenges that are targeted very specifically at only current technology. And so we found that to be extremely difficult to do without either over-regulating it and coming up with a requirement that was too restrictive and required a lot of resources that might not help us in the field, or the opposite, which in that we've got something that people can find a way through fairly readily that doesn't really represent the field, which is why we ended up settling on finding representative field operation at light load and assembling that into a cycle. And unfortunately, given some of the lower temperature challenges and things, that's very difficult to do in a short period of time, and really present several representative challenges. I suspect that's going to be a more difficult thing still when we try looking at the non-road market and developing an LLC there.
Thank you, Chris.
Thanks, Chris.
The next question we have is for Jenna at 103. This is from Jeff Ham. If all tier 5 equipment is listed on doors and the label is affixed to the engine, is it possible to include a QR type of label to allow accuracy and reporting and review/inspection?
Yeah, this sounds like it's more of a question for the in-use in the in-use off-road diesel reg. So I really couldn't answer for them, but we can certainly let them know this. And I think we have to keep in terms of, I think you're speaking of, for clarification, I think you're speaking of I don't know if you're speaking of the engine label or you're speaking of the ID number that's on equipment. But we have talked about, using a QR code in addition. That's something we've talked about internally, but it's not something that we've fleshed out yet.
Thank you, Jenna. Currently, I'm not showing any questions that like we have a response lined up. Should I go through the list that I have currently? We have Kim here who would like to
Here, I can
answer.
take one. So Edward Phillips at 1232 asks, will a 1000 brake horsepower tier 5 diesel engine give more reductions than 140 horsepower tier 4 final diesel engine coupled with a 150 kilowatt battery pack? And I don't have the calculation done for that, and it would require, like, you could make different assumptions would give you a different answer. But I think the broader point that Mr. Phillips is trying to make is that sometimes hybridization can be a great technique for cutting emissions. And I think we recognize that, and we're interested to hear further feedback from folks regarding, what elements related to that should be included in this rulemaking. So thanks for pointing that out.
I can take the next one too. Let's see, it says, question based on Steve Berry's idea that PEMS is already a complex process from a certain perspective. Is CARB considering a closer communication with EU, Korea, China authorities, for example, to develop a common testing and analysis procedure? This would harmonize a process that is already complex, as already mentioned. So yeah, thank you for that comment. And we have reached out to the EU, and we'll be having discussions with them. I think that we have definitely started to look at their programs as well. So thank you for that comment.
Thank you, Jen. The next comment is maybe for Jeff Laurie. This is from his favorite guy, Anonymous, at 112.
My favorite
presenters made.
Right. Go ahead.
I'm sorry. Presenter made comments about affecting disadvantaged communities where these tractors and other equipment stored or operated to support this. I don't see a lot of green or red tractors in South LA. As far as construction like highways and such, I just see happening to fix the roads and then leaving. I see more dust and smells from the construction and asphalt than the equipment.
Yeah. So the issue here, and I brought this up in the presentation, was that off-road equipment, it's not exactly stationary, but it tends to stay at a location for a longer period of time than a truck that's, delivering packages cross country or cross city. And because off-road standards have lagged the on-road standards, they are now presenting a greater cancer risk to disadvantaged communities. So appreciate the comment. I'm glad they're not seeing, or smelling the diesel plumes from the off-road equipment that's near them, but this is a concern to us, and it's something we'd like to rectify as soon as possible.
And I should just point out too that we definitely appreciate folks' comments and questions. And even if you prefer to remain anonymous, that's totally fine. We're being a little bit facetious.
The next question is OBD related and directed at Mike here. This is a comment, not a question. OBD is not intended to ensure standardized data available for data collection of in-use monitoring. Requesting manufacturers to follow J1939 could accomplish this goal.
Yeah, well, I guess thanks to Anonymous for that comment. I do like the thinking, honestly, but I suspect that it's not so simple that we just sort of ask for the data and then it's done. While many manufacturers may comply with a simple request like that, if they don't comply with it, we wouldn't really have the ability to enforce compliance with our standards, and we wouldn't have the ability to run these in-use compliance test programs and generate data that are enforceable. So I think in reality, it's something that we need to do. We need to put in regulation so we can enforce the data, and so that testing programs that are run or based on that data are also enforceable.
Thank you, Mike. I think Kim would like to take a question from Michael Ross.
Yeah, 127. Thanks, Christian. Michael Ross asks, will LSI emission standards be aligned with Tier 5? Currently, the standards are higher than Tier 4. We hadn't been thinking of addressing LSI emission standards as part of this rulemaking, but if folks think we should, please let us know that. Because we're at the beginning of scoping this out, so it's something we could consider. Although there's, as you could tell from today's presentations, it's already a very large scope here. Thank you for the question.
Thank you. And the next one here is from Anonymous and directed towards Jenna at 150. Do you consider to include zero emission targets for GHG requirements?
Yeah, I wasn't quite sure what they were asking here, but I'll just take a stab at it and create my own question. I think you're asking if we have GHG targets in our Tier 5 reg, and the answer is yes. We're considering CO2 targets we do have CO2 emission targets for Tier 5.
Thank you, Jenna. On my screen, I don't see any more open questions, but I did log out and maybe missing some questions from before our
I think break. That Stefan is trying to say something.
Yeah, I accidentally moved it over to answered, but let me read the question. I was going to try to address it. And it would have been also good for Chris to address it, but it was an anonymous attendee at 11:57 a.m. Has any work been done to quantify the ability of instruments to repeatably and reliably measure emissions at these target levels? And I know with the work that we did on the omnibus in the lab, we were able to do pretty good repeatable measurements with test cycles in the lab. It's much easier to do. PEMs use similar analyzers, but of course in the field with PEMs you have more variability of the environment, so there's some consideration that needs to be done, and so we did take that into account in our setting the emission standards for the in-use using PEMs.
All right, thank you, Stefan. So do we have any raised hands left over?
No, we don't.
Okay, well, terrific. Well, I think that pretty much wraps up our first public workshop, and we really appreciate everybody who stayed for the overtime and through the lunch break period. And please send us your questions and your data and your feedback and your proposals as well. And
Jenna, you're going to be posting a short summary of the specific areas where we requested data, right?
That's correct.
On our website. That'd be awesome. Okay.
Yep, as well as the Zoom recording. That will be through a YouTube, and we'll get that out to everybody as well.
Awesome. Thank you, everybody. Great job, team.
Thank you. Bye-bye, everyone.
Bye now.